The math does not work for evolution. And we've known this since at least 1966. If you disagree, I welcome you to join me and bring your math. After I've done my presentation showing the math problem with evolution, then I invite anyone to join and bring your math if you disagree. And I don't think anybody's actually going to be able to do that because I did ask AI and tried to get AI to see if there was something to refute what I'm about to present to you. And I wasn't able to find anything. But hey, I'm open. If anybody thinks that they have the math to solve this, then great, you're welcome. But if not, then you can also join after I do my presentation and share any evidence that you want for evolution. And so let's just start with this. What is evolution's math problem? So let's start with this number right here, 10 to the 1/40th power. Okay. Now I want you to keep this number in mind as we go through this, because this will help you kind of keep in mind the enormous numbers and things that we're dealing with. So this was calculated by William Dembski, and this he calculated as the total number of events possible since the beginning of the universe. If we go by Big Bang time, then the number of total possible events. Now, the way that he got this number is that he took the number of elementary particles, the number of seconds since the Big Bang, and the number of possible interactions per second. Okay, so of course, there's been some time since he did this, but not that much. Okay, so keep that number in mind as we talk about since why we've known that the math does not work for evolution since at least 1966. So in 1966, a bunch of mathematicians, physicists, scientists in various fields got together for a symposium at the Wistar Institute. And it was because these, scientists and mathematicians from MIT said, you know what? The math just does not work for neo-Darwinism. This is not going to work out. Like, we need to talk about this. And they went around and they got a bunch of people together and they had this symposium. Okay, so let's talk about some of the people who were at this symposium and the arguments that they brought. And by the way, this image that I'm showing is the book that they made that was basically the transcript of this symposium. And I haven't been able to find this except for one chapter. And the one chapter I read is riveting. I'm trying to get a hold of the rest of this because it is so good. So here's one of the scientists who was at that symposium. And I don't know how to pronounce his first name. It's something like Stanislav Ulam. And so his argument, he brought this math, and to be perfectly honest with you guys, I don't do math. I have no idea what this equation means, okay? So if somebody comes on here and argues with math with me, then I'm not going to have anything to say about it because I don't do math. But if somebody wants to bring their math, great, because it'll be on recording and then I can look it up later. I can ask mathematicians and we can see if their math is correct. So, but anyway, Dr. Ulam said the required number of successful events, mutations for changes to an organism is not possible. So when he worked out the math, what it would take to change an organism, he said, this just does not work. And so then we had another person who agreed with him. So Marcel Paul Schutzenberger, he brought, the same complaint, but he said, look, we have now come to the age where we can actually use computers to simulate this. And he said, look, when we do computer simulations, we cannot, through making random typographical changes, which are analogous to random mutations, he says it invariably, almost invariably destroys the program's meaning and function, and it doesn't create a slightly better or functional new program. The very least it will do is just jam it. So he said, this is not going to work. Like you're saying we can make all these have all these random mutations happening, and the number of random mutations that we need in order to get one that might be slightly beneficial, by the time you do that, it's just going to be too problematic for the organism. So, then we have Murray Eden, who said, look, I know a lot of people have seen modern day calculations for trying to see how a protein, amino acids could come together to form a protein. And that's what Murray Eden was trying to do. He said, look, considering the biosphere size, cell density, protein concentration, and average protein lifetime. I have the comma in the wrong place here. Sorry about that. And he calculated the maximum number of trials, and he gave 1 second for each trial in his calculation. So, like, the to try, to get basically the protein sequences, he gave one trial per second. He said the their chances, their trials is infinitesimally small compared to the 10 to the 325th possible sequences. So he's like, look, this is not going to work. You're not going to get these functioning proteins. You're not going to get the changes that you want. There's just too much space, too much possibility, and there's not enough time for this to be able to build these changes within the organism. He argued that a single ordered pair of genes through random genetic transfers would require something like 10 to the 36th genetic transfers. So this is just, as you know, many genes have to work together in order for things to function within an organism. So some functions require many genes. And he's like, look, if just to even get an ordered pair of genes through these random genetic transfers, there's no time, there's no space for this. This cannot happen. And so these are some of the arguments that were presented. And this has not been refuted to this day. When I asked AI, like, what are the arguments against this? AI at first produced some things for me, but then I saw that what it produced when I argued with it, it actually got so confused that it was like, okay, it kind of gave up. It actually changed it didn't say it changed its mind, but it originally presented Fisher's theorem as a refutation of this. And then as I kept talking to it, it said, well, actually, Fisher's theorem kind of was arguing in the same direction that these guys were arguing. So anyway, the point is, I don't think there has been anything that really responds substantively to the problems, the combinatorial math problems that these guys brought. And this is a problem that persists today. And, even back in 1983, Sir Fred Hoyle made this calculation. Now, this is more of an origin of life thing rather than a mutations bringing about changes in organisms. But he calculated the odds of getting the proteins to service a single cell by chance. So within a single cell, you have many proteins that have to be in place working together. And if you don't have that, we've tried to knock out proteins and genes in cells to see what's the bare minimum that they could live with. And it's something like 400 genes as far as we can tell. And so it's really tough to get all of these things working together. Really tough is like really an understatement. Okay. Remember this number, 1 in 10 to the 40,000th. Okay. Think back to the number I showed you earlier, 10 to the 140th. Okay. That's how many possible events. If things happen according to the Big Bang timeline, that's a number of possible events. And so evolution is just, it's so improbable, it should have been disregarded as impossible a long time ago. There's no resolution to this. All the resolution is ignoring the problem. Okay. So if anybody wants to challenge that, I totally welcome you on. Please come and bring your math and show me why I'm wrong. Because right now I said, this is my evidence that I'm bringing against evolution, and it's just math. Okay. So if you disagree, bring it. And if not, then I'm just going to go ahead and review the things that I've brought before and remind you of the reasons, other scientific reasons that you should reject evolution. Now, this is the list of challenges that I have brought against evolution. And so far, no one has challenged me on these. Okay, there may be one at the bottom that someone informally challenged me on, but they didn't bring their evidence. So bring your evidence if you want to challenge me on any of these things. The evidence against evolution is very strong. And so I'm going to give you 6 reasons now, 6 scientific reasons to reject evolution. Okay, I have a religious agenda. I want you to know God loves you. God created you. Jesus died on the cross for you. I want you to know that. That does motivate me. That's why I'm doing this. But I'm not trying to give you any religious argument for why you should reject evolution. I want you to know the truth about reality, that evolution does not work scientifically. You should reject it on a scientific basis alone. And so the first reason you should reject it is that the proposed mechanisms for evolution are grossly insufficient for building the diversity of life that we see today. Okay, grossly insufficient. And I hope you saw the math problem with that. Look, mutations, often deleterious, sometimes neutral, and like very occasionally could provide some benefit, but you've got to figure out how all of these things are going to come together and put and bring new organs, new systems, new features into an organism. And we have somebody joining to challenge me. So let me figure this out real quick. I gotta take that off. Hey, Dr. Feldman, how are you?
Yep. How are you doing tonight?
I'm good. Have you
Well,
brought evidence for evolution?
you said there was no refutation of the probability arguments.
Yeah,
It took me, and I'm not exaggerating, maybe 10 seconds to find an article that completely refutes all those
great. Let's see
possibilities.
it. What's the
The article
article?
is called "The Failure of Mathematical Anti-Evolutionism" by Jason Rosenhaus, published in Skeptical Inquirer in the May-June issue of 2022.
What's the argument?
Okay, so here's the argument. It was exactly the one I thought that they were going to use, that the assumptions about how the proteins are constructed are false. That you're assuming that you have to construct a finished protein from random chance. And so the analogy that he uses in this paper, and I just very quickly read it, so I apologize if I'm mangling what he
Okay.
said. Here's the analogy. If you have, say, a big tray with 1,000 pennies, and you say, what is the chance that I'm going to flip that tray and get 1,000 heads? Well, it's infinitesimally small.
Yes.
But that's not the proper way to construct the argument. The proper way to construct it is it's a process of selection, that each stage in the process has some benefit to the chemical evolution, or if there's already a living organism, the organism evolution. And so the proper way to construct the probability is you flip the tray once and you remove all the heads. And you flip the tray twice and you remove all the heads. And you only have to flip the tray maybe 10 times to get 100% heads in 1,000 pennies. And so the way that they're doing the calculation is making false assumptions about the way the proteins would come together rather than Darwinian evolution. And so you can basically toss out all those arguments. And this has been a mathematical refutation of that argument for decades. It's nothing.
No,
It
look,
feels,
I'm
and if
going
you're
to
going to
end this
say,
right
let
now.
me finish.
I
If you're going to say
totally reject this.
if you're going to say you disagree with that argument, that's fine. But don't say it's never been refuted and there is no refutation, because
No,
that's not true.
it
And
is.
it seriously
Look,
took
it's
me.
a refutation if the argument is sound, right? If it's valid. But this is not at all a valid refutation. Not at all. Okay.
Well,
So
then don't say there is no refutation if there is, and it's
there
published. If you
isn't though a
I don't know
refutation.
why you couldn't find it. It took me 10 seconds.
I saw that myself. Okay. So what you're saying, when I say there's no refutation, I mean I tried to find a good argument against this, could not find one. Okay. So I'm going to tell you right now why what you just read does not work. It does not work because having a partial protein does you no good. If it's not a functioning protein, there's no selection for it.
How do you know
So
it's not functioning?
we're trying to get to a functional protein. So how do
Well,
you get to a functional protein?
you don't know what the smallest number of amino acid is. It amino acids to make a functioning protein is. You don't know what that answer is.
Well, I don't know it off the top of my head, but I think maybe some of the smallest ones are like 150 protein amino acids. But let's just look it up. Let's
What
just
doesn't
figure that out
matter
right now.
is today. The question is, what would have been the smallest one in the past, and we don't know the answer to that. And so you're assuming that there can't be a smaller protein than the ones that exist today, and that may or may not be true. We don't know. And so you have to make all these false assumptions for which there's no evidence to get to this probability. And
Okay,
it's a very different thing to say you don't agree with the refutation than to say there is no refutation. Those are two very different statements.
it's look, why is it that most of the time when people come on here, they want to play word games?
I'm
Okay.
not. I'm not.
I look, just let's decide on what the word refutation means to you. If you think anything can suffice for a refutation, then okay, I won't use that word with you. Okay. But I'll qualify it with something like a good refutation. Okay.
That's a
So
better way to say it. I
there's
wouldn't have
no
any.
good refutation.
Okay.
Okay.
But
So
that's a very different way to say it than, the way you were saying it suggests that nobody has ever published a refutation of it, even if you disagree with it, which isn't true. And this is a refutation, even if you don't agree with it. So if you say no one has published a refutation that I personally agree with, that I would have no objection to.
it's not that I personally agree with. Okay. It's that doesn't stand up to scrutiny, period. Does not stand up to scrutiny.
I
So
just,
it's not about my opinion. It's
it
that
is
it
about
does
your
not stand
opinion.
up to scrutiny. Anybody could publish anything. And I mean, would you accept anything as a refutation? Anything?
Well, I accept that there are people that know a lot more about probability than I do. And I
Okay.
accept that there are some pretty deep flaws in the way they're doing these calculations. They assume they have to get to a working protein that's similar to a working protein today. And in the past, we don't know. I mean, there's a lot of gaps in our knowledge about how life evolved.
Oh,
Doesn't
gaps. It
mean
sounds like you want an evolution of the gaps. You're going to believe it and call it science, and until and no matter what, even if it contradicts everything we say, you're going to appeal to evolution of the gaps.
there is no physics or evidence that says that we can't eventually fill in those gaps. I mean, we
Actually,
know a lot more today about evolution than we did 100 years ago, and I assume in 100 years we'll know even more, and 100 years later we'll know even more.
yes, but if you want to hold a scientific view today, the scientific view is that this evolution contradicts many of our scientific observations. It contradicts these math calculations of probabilities. It contradicts contradicts what we know about chemistry, getting life to emerge from non-living chemicals. This, if you want to be scientific today, you should believe what the science shows, which is chemistry cannot produce life by natural processes.
What's your evidence for that?
My evidence is every scientific experiment that has ever been done on trying to get life to come about from chemical processes. Every single experiment shows that life does not come about by chemicals. You have to, of course, life is made up of chemicals, but you cannot get life. We can't even produce it, even using our intelligence. We can't get life to come.
Can you prove? Can you prove to me that an experiment won't take place tomorrow that will successfully produce life?
No, I'm asking. Okay. No, I can't. But what I'm asking you to do is be scientific today.
Well, I think
be scientific today.
Well, what science is the scientific method. That's what defines science. And there's nothing in the scientific method that proves that we can't get life from non-life.
Actually,
we haven't done it yet, but that doesn't mean it won't happen in the future. And just because we haven't observed anything happening yet doesn't mean we won't observe it happening in the future. Just because we haven't had a successful experiment yet doesn't mean we won't have a successful experiment in the future. There are some things that we know cannot happen. For example, if somebody said, the Earth stopped rotating for a few minutes and then started rotating again, well, we know that violates so many laws of physics that it's not possible that it could happen. Even though we've never observed it, it wouldn't be possible. But there's no physical law that says life can't originate from non-life. It's just that we haven't observed it yet, and there's certainly a lot of steps that we do not understand. But that isn't the same as saying it can't happen. And these probabilistic arguments fail because they're trying to create a random probability to get to life we see today, but we don't know what those early stages were. And so that's the probability you have to calculate, which frankly is impossible. And so the analogy that I started with is actually absolutely valid. And you just are making these arguments are making false assumptions.
Actually, what you've shown me is that you are having faith in evolution in spite of the scientific evidence. Look, this is From Matter to Life. Okay. It's a book about the origin of life. Okay. Trying to get, this is discussing the problem of the origin of life by people who actually still believe that, life came about by natural processes. Okay. So, and this is, Paul Davies and Sarah Amari Walker that wrote this chapter, and they say what we term. Are you listening, or are you looking something up?
I'm Googling some stuff and I'm listening to you, so that's why I'm not looking at the camera. I'm looking at my other.
Okay.
Screen. But I am listening.
All right. They say what we term the hard problem of life is the identification of the actual physical mechanism that permits information to gain causal purchase over matter. This view is not accommodated in our current approaches to physics. Okay, so they are saying this in another place. They say, look, we don't know. We need new physics in order to get life to come about in this way. So that is where the science stands today. Right now, you already told me you're not being scientific. You're having faith that we'll figure something out in the future. But right now, if you want to be scientific, you should believe life does not come about by chemicals and natural processes.
Well, I have to look at that book. I have heard of that now that and it was based on a conference, as I recall. And that I would have to look at the expertise of the people that were involved. What I've seen a lot in in paleontology and evolution especially is that people who are not specialists try to delve into it and don't really understand what they're talking about. So without having read the book, I'm not going to comment on it. But
Yeah. And you don't have to read this book. You can look at anything, look up any article on the origin of life, and you're going to find that what I'm telling you is true. There
well,
is no explanation for life coming about by chemical processes. We're not even close to that. So
that
all of the science is behind me, every bit of
well,
it.
there's two different. You're conflating two different arguments. One argument is that there's no explanation for how life evolved, which is absolutely true. There's no comprehensive explanation, but that doesn't mean it didn't happen. It just means we don't understand how it happened. For a long time, there was no explanation about why the planets were moving in the sky, and then Newton figured it out. And so, for every scientific concept where we have an explanation today, there was 1,000 years in the past when there wasn't an explanation, or 2,000 years, or 3,000 years, however long there was that people were thinking about this. I mean, Newton didn't really have much information that the Greeks didn't have or the Egyptians didn't have, and yet he figured out, what was going on with the planets that nobody else did. And so, for every scientific explanation, there was a period of time that lasted potentially thousands of years when there was no explanation. So, the fact that there is no explanation today is not evidence that it didn't happen. It's not evidence that we won't have an explanation in 100 years or 1,000 years. You don't know. Then there's the second argument, which you made from that book, which says that it violates some law of physics. And that's a very different argument. And if that's valid, that would be argument against evolution. But the lack of an explanation today is not an argument. It won't convince any scientist, that's for sure. And with good reason, because for every explanation we have today, there was a moment of discovery before which we didn't have the explanation. And so you can't predict what we will have an explanation for in the future. So those are two very different arguments that you're conflating.
Right. And that's true. But do you see the difference? Like I'm saying, let's be scientific today, which includes the hope that you could find an answer. But today, what should your position be if you're being scientific?
That we wait for some testable hypothesis that we can go out and collect data. That's what science is. Science isn't a series of facts; it's a method of obtaining information, and the method is the scientific method. And there's nothing in the scientific method that says we won't discover eventually some series of steps that gives us life. Maybe we
Right.
won't.
But after we do experiment after experiment, how many experiments would it take for you to say, okay, it looks like right now my position should be that life cannot come about by natural processes. I'm open to changing that if by the scientific method we find something different. But today I'm going to go according to our scientific observations, and they are pointing very strongly in one direction.
No, it doesn't matter how many failed experiments there are. That's not the way science works. You've got a fundamentally flawed understanding of what science is. Look at it this way. For the ancient Greeks, and I know I'm mangling things a little bit here, they observed that nothing moved without a force. If you had a donkey pulling a cart, as soon as the donkey stopped, the cart stopped moving. If you had wind blowing a ship, as soon as the wind stopped, the ship stopped moving, and on and on and on. And so they said, nothing moves without a force. You have to have a force for something to move. And then, 1,500 years later, 1,500 years later, Newton figured out that wasn't true. And so you could have 1,000 years of experiments showing that we don't have an explanation, and then somebody figures it out. It's not evidence that it's not true. It doesn't matter how many experiments because the logic that you're using is flawed from the start. It doesn't matter. Now, if you have evidence that the creation of life would violate some law of physics, that's a very different argument. And without reading that book, and I'm probably not going to because I've got books of my own that I'm working on, um, I'm not going to get into it. But those are two different arguments. You really should abandon your use of saying we don't have an explanation for something, therefore it's unlikely to have happened, which is exactly what you're saying. And you should abandon that explanation. It
No.
has been shown repeatedly to be false.
I'm arguing from what we have shown via scientific experiments. I'm going on our what we have observed right now. What you're trying to get me to do is say that all of our scientific observations right now are meaningless, that they can't point us to
No,
anything.
I'm not
Because
saying that
then
at all.
when do those scientific experiments get to actually make an effect on what we believe about life?
When they show that the evolution of life is absolutely impossible because it violates some
It's already
physical
been shown.
law, which, as far as I know, has never been
Yeah,
shown.
it's been shown.
But
It's been
if
shown.
you
Let
have,
me put the number back up there for you.
it
Let let
doesn't matter because
let
it's a false calculation. They make
you're
assumptions to calculate that. I mean, Fred Hoyle had also some bizarre ideas. He thought that life came from another planet, and he had some really. I mean, obviously I never knew him.
well, and you can attack the man, but that's another thing people like to do when they can't make
Well,
an
fair
argument.
enough,
They
but it's a
would
bad
rather
way to do
attack the
it. I agree.
person.
I agree. I shouldn't
Okay,
have.
but and I'll tell you that that calculation has also been made by other people who got very similar calculations, very similar results, maybe slightly
But
different, but very similar to
but
his.
saying that there's a bunch of failed experiments doesn't mean that we haven't learned anything. With each failed experiment, we learn one way that it didn't work. But that doesn't mean that there's no ways it didn't work. And again, I go to the ancient Greeks, where they knew positively that nothing moved without a force. And over 1,000 years later, Newton figured it out. And so we have lots of history to show that when you say we don't have an explanation for something, isn't evidence that it didn't happen. It's zero evidence. It's not even a little bit convincing. It's because you're using a flawed understanding of the way this kind of logic works. Now, if you have an argument that says it's impossible, that it would violate some principle like information theory, which I've seen arguments against that doesn't work. Um, that's very different. But as far as I know, all of those arguments have failed also for information theory. There's good reasons why it doesn't apply to life because life isn't a closed system, and so entropy, the decrease in entropy doesn't work, and the second law of thermodynamics doesn't apply. But as far as I know, there's using this line of reasoning, and I've seen you use it before. There's no good mechanism for evolution, which also isn't an argument that works because you're relying on the lack of an explanation, which is out of the gaps. And so I'm not saying that proves that evolution did happen. I'm saying it just isn't a good explanation for why evolution didn't happen. And so, I keep going back to the fossil evidence, which for me is very convincing. And if you're kind enough to invite me on to present that evidence, I think especially in context of stratigraphy, it's extremely convincing. But
Yeah, of course. I told you you're welcome to. I've been waiting for you.
it's up to me, so it's really it's going to take me a while to get copyright permissions to show some of the figures I want to show. But I am drafting things. But
Well, Wesley Coleman brought up, and you brought up information, and he says information is meaning, which is not reducible to physical laws and chemistry. And this does bring up, look, you brought up, information, which information is a that we can from just our we can do another probability calculation based on that, okay? Because life is full of information.
mhm,
And the only known source of information is intelligence, okay?
I
Information does
disagree.
not come about. It
I
does not come
disagree.
about. What?
The only source of information is human intelligence. Do you have another example?
No, I don't, except
Okay.
for the information in life. Okay. So what would be a better way to think about the information in life? Did it come about by natural processes which can be demonstrated to not bring about information? Or is it better to recognize that that came from an intelligent source?
Why should it be an intelligent source?
Because we do not know how to get information. Like information, we can actually demonstrably, this isn't a, oh, this is, we can demonstrate, and we have demonstrated over and over again that you cannot get information without an intelligent source. So why would life get to
Without a
be the
human
exception?
intelligent source. You don't have any other examples. Let's be scientific. You don't have any other examples other than human intelligent source, right? Am I
That's
wrong?
true. That's true.
Okay, so then by your logic, all the information in life must be designed by a human because you have no counterexamples.
No, because I accept I'm not limiting myself. Look, I accept that there may be sources of intelligence, the other beings that are not human.
Okay, and I accept that there may be other mechanisms for evolution that you haven't yet evaluated.
Okay, what do you propose as a source of information?
I think natural selection works very well. Yeah.
Natural selection can make information?
Mhm.
Okay.
Well,
Where is it in
you had a
science that
guest
would show
on
that
who
to
gave you
be
examples.
possible?
You had a guest on who gave you examples of beneficial mutations, and every time there's a beneficial mutation, there's an increase in information. It's very, very tiny, but there is an increase.
But nature can only select from what is already present. So every time you're talking about a mutation, you're talking about organisms that already have a ton of information. So where does that information originate? Where did it come from?
Natural selection.
How does nature select from what is not already present?
Well, here's one example that we know that when cells um, reproduce and the DNA molecules reproduce, they can duplicate. Chromosomes can be duplicated, or portions of chromosomes can be duplicated. So now, originally you had, say, one coding for a protein, and now you've got a duplicate coding for that protein. So if one protein keeps the same function, the other protein can evolve to a completely new function. So now you've gone from one protein to two proteins. So that's an increase in information. And we know, although nobody has ever observed the entire succession, we know each step in that process works.
But do you notice that you've started with code? So
Yeah,
where did that code come from?
I don't know. From as I said, the origin of life is not well worked out. There's a lot of steps we don't understand, but that doesn't mean it didn't happen. It doesn't mean that we won't understand it tomorrow. The fact that we don't have an explanation today isn't evidence that there is no explanation. If we had some law that said it can't happen, then that's fine. But there is no law that says it can't happen. The decrease in entropy is only valid. Um, I said that wrong. People talk about an increase in entropy, but that assumes there's no energy being added to the system. As long as you're adding energy to the system, a decrease in entropy is fine. If I'm
Okay,
hearing
so you're willing to say that right now a code came about by natural processes.
Mhm.
Okay.
Let me rephrase that. I know of no evidence that it didn't happen.
Okay. What about our experience that code does not come about by natural processes?
So that's a form of empirical logic that has been rejected by science for several hundred years, and creationists keep using it. There's a lot of examples where people said, "Well, we've never seen anything other than this," and then later there is an example other than that. And so you can't use that as a logical to draw any kind of logical conclusion. And this goes back to the ancient Greeks, where they said nothing moves without a force being applied to it, and when the force stops, the motion stops. And 1,000 years later, or more than 1,000 years later, it was discovered that wasn't true. And so the fact that that every time we've observed something, it ends up a certain way, isn't evidence that's the only process. It's just not. And you can continue to use that logic. But like I say, that logic has been rejected for hundreds of years.
Okay. Well, I thought, and maybe I was wrong, that science was about our empirical observations of the world.
No. No,
Okay,
that's
so it's not about observations.
it's partly about observations. It's about the scientific method. It's about
Okay,
developing
yes,
hypotheses,
exactly.
using those hypotheses to make predictions, and then
Yes.
going out and collecting data to see if those predictions are true. I'll give you an example from geology because this is something I like a lot that I've been reading about. There's I don't have it with me. There's a book that came out on the discovery of plate tectonics that describes this. And I'm grossly, like, totally simplifying the story to make a point, but the story is more or less correct. That when plate tectonics was developed, there was a lot of consternation. And people said there's no known mechanism. So Alfred Wegener in 1912 proposed that the continents were all joined together, and he had lots of geologic evidence from the continents to say they were all together. And especially in North America, virtually every scientist in North America said that's not possible because there's no mechanism. They're using exactly the same argument that you're using, but they were all wrong. Eventually, there was a mechanism, and the mechanism was the circulation of the mantle due to heat plumes. So you have hot mantle coming up, going up, and then coming down. And so it was, what's the name for um, convection? Convection. And then in the 1960s, and I'm shortening a story that is very complex and with parallel moving parts, but essentially what happened was they had already discovered that the Earth's magnetic field had reversed many times. That discovery goes back to first in the 1920s, but it was really solid by the 1950s. The Earth's magnetic field had switched many times. And so then they said, well, if plate tectonics is true, we can make a prediction about the magnetic field preserved in the oceanic crust about the mid-Atlantic ridge, and that if the alternate theory, which was something you've never heard of, called a geosynclinal theory about how mountain belts built, is true, and that the Earth is static, then those magnetic stripes shouldn't be there. But if at the mid-Atlantic ridge new crust is constantly being created, it should preserve the fossilized magnetic field of the Earth's magnetic field at that moment in time. And so then they built the devices, and I'm greatly shortening a very complex story, but they built the devices and they found the magnetic stripes in the ocean basin exactly as predicted by plate tectonics and as contradicting the static continent model. So that's how science progresses. It's by making a prediction, going out and collecting data to test that prediction and see if the prediction is true. Now, here's the big difference between science and religion. If those magnetic stripes had been absent, it would have forced people to reject plate tectonics. So that's a key element of science, is that the hypotheses are falsifiable. And that's what science is. So it's a
Okay, good.
combination
Thank
of
you. Thank you.
making
So you
it,
can falsify it. So that's
it's potentially falsifiable. Not it is falsified, it's potentially falsifiable. That every
okay.
hypothesis needs to potentially be falsifiable. Now, having said that, there are hypotheses where we have so much data it can no longer be falsified. An example of that is at one time it was a legitimate scientific question about whether the Earth went around the sun or the sun went around the Earth. And now, that was a falsifiable hypothesis when Copernicus and then Galileo said the Earth went around the sun. Now, those were legitimate scientific questions at the time, and now we know. I
Right.
mean, you can't go back. We know that
Okay,
the Earth
good.
goes around the sun, so it is
Yeah,
no longer a falsifiable prediction.
right. And so why is it that the methodology that you're describing right now is different than the approach you're taking when it comes to the origin of life? Because it sounds like no matter how much evidence stacks up against it, you're still willing to give it the benefit of the doubt.
No, it's that there's no falsifiable hypothesis. There's no falsified prediction that has happened. So we know a lot about what ways that life didn't originate because of all those experiments. Experiments. There was a lot of excitement in the 1950s and 60s because there were experiments that were producing all these organic compounds without any. And there's an example where if you had done those numerical probabilities, you would have failed because you would have predicted that, say, amino acids could never be produced without some sort of plan, but they did. And so we don't know, we know amino acids and nucleic acids can be produced through random processes. This has already been proved in the 1950s. And so
Amino acids, yes, but the type that we need, like the homochiral amino acids, do not come about by natural processes that we have seen.
what's homochiral? I don't know what that is.
Okay, so every amino acid, okay, it's kind of like you have
Yeah,
how I have two hands and they are different shape, but I mean they're the same shape, but they're opposites.
mirror images.
Yes, they're mirrored images. So every amino acid has that same thing. Okay. Now, in non life, amino acids that are not part of life, they are a mixture. They're always like a 50-50
Yeah,
mixture.
right.
Okay. But in life, they are almost all left-handed amino acids. There are some exceptions to that. You can have some breakdown and degrading, but in life, you have to have all left-handed amino acids, and that does not just happen. We don't know how to get that. So when Stanley Miller and Urey did their experiment, they got a mixture. They did not get amino acids in a homochiral form, which is what you need for life.
Well, first of all, we don't know that's what you need for life. We know that's what you need for our life. We don't know if there's other versions of life that possibly, you said there could be other intelligences in the universe. Maybe they're all right handed molecules, or maybe they're a mixture of left and right handed molecules. We have no way of knowing that. And so we know that all life today ended up with left handed molecules by and large, and we don't know why. But again, that's not evidence that evolution didn't happen. It's just evidence that there's a step we don't understand. And so that's a very different argument. And so, as far as I know, there are no um, hypotheses about the origin of life that have been falsified to the point that means it can't have happened. And so that's the way science progresses. If you want to prove science, prove evolution didn't happen, find a falsifiable hypothesis and go collect the data and show that it's correct or incorrect or whatever. But that's what you'd have to do. And as far as I know, your reasoning against evolution is no longer falsifiable. You're so convinced, whereas I'm absolutely it could be falsified. If there's physical laws that prevent the origin of life, that would falsify it. If somebody finds the classic example that I'll repeat is the Precambrian rabbit, if somebody finds a Precambrian rabbit, man, all bets are off. So there's absolutely things that could happen that would falsify evolution. I don't think there's anything that could happen, any evidence that you would ever accept that would falsify your belief that evolution didn't happen.
Well, actually, I mean, I try to be scientific in my approach to evolution, and I have from the beginning. Okay,
I
so
don't think you have, because I think your explanation of science isn't correct. And I'm not trying to insult you because you don't come from a scientific background. I mean, I've been studying the philosophy of science for decades now, and I have a pretty good understanding of it. I understand the history, and it's all based on falsifiable hypotheses. Now, there's a lot of discussion about what science is, and no matter how good a definition you come up with, you can find exceptions that people say, well, that probably is science, but it didn't happen that way. But that's the generally accepted definition of science, is that it's producing a falsifiable hypothesis and collecting data to determine whether your prediction about that hypothesis is true.
well,
That's
I don't disagree with that, and let me put this up so we can see what you would say to this. Chad says, Rebecca, can you ask Howard how we could falsify the theory that the genetic code came about through natural processes?
there's that you could find some physical law that would prevent it from happening, that everybody would agree with, that would do it.
Can you give like an example?
Well, since I don't think there is any such physical law, I can't give an example. But if you could find some physical law, some law of physics or some law of chemistry that everybody can agree is true, that would there would be some critical step in the evolution of life that would have to happen, and yet you could prove it could not happen. That would falsify it.
So would there be any number where the probability would get so low? Like, let's just suppose for a minute this was accurate. If this was an accurate, uh, if this number was accurate, if all the calculations were correct, would this be enough? 1 in 10 to the 40th thousand? Would that be enough?
I'm not going to answer a hypothetical. I think we have so much evidence that the assumptions that go into these kinds of arguments are not correct, and that you have to assume things being random that aren't random. And so, if you assume that to make an amino acid, you need a series of random events that are so unlikely as it can't happen, we know that's false. And so we don't know, given enough time, we don't know what else could happen that would happen by natural processes if you had an experiment run for, say, 100,000 years. We don't know what the
Okay.
would be. And
Well,
so that's very different from saying there's a physical process that cannot possibly have happened that you need to have happen for life to occur.
and
So,
that's the problem with trying to do this does demonstrate the difference between like observational science and historical science, because you said, look, there's so much now that shows, look, that we don't live in a geocentric universe, or a geocentric solar system. There's so much evidence against that right now, right, that we can safely rule that out. Okay.
mhm.
But we can make observations right now that will show us that, right? But
Like what?
the problem is we're talking about events in the past,
Yeah.
okay, that we can't repeat. So we have to approach it a little bit differently, right? And what I hear you doing is that you're saying basically, like, you're you're willing to take on faith that it happened, and it doesn't matter how many things that we show that are against it, because you're going to continue to hold out hope that we'll find an explanation. Whereas
No,
I
that's
think
not
we've
true. I'm just
demonstrated, I
saying we
think
don't
we've
know.
shown.
I'm
Go
not
ahead.
holding out hope. I'm just saying we don't know.
Well,
And
faith,
I'm
you
just
have
give
faith
me a
that we
second
will
to
find
look
an
something up.
explanation.
Give me a second to look something up.
Andrew says events in the past leave evidence today. The events themselves don't need to be repeated. Otherwise, nothing in forensics would be possible. Yeah, I'm not
Well,
saying that there's no evidence we can look at. Actually, I think there's plenty of evidence that can show us that
I want
thinking
to get.
abiogenesis
I'll
happened. And
address that point, but I want to go back to what you
all right.
said. You were talking about origin science versus experimental science, and so it's worth understanding where that concept came about. And so that's from a book, and that's why I was looking up because I wanted to get my information. A book by Norman Glaser and Kirby Anderson. Norman Glaser just died maybe 2 years ago, but that book was written in, I think, does it say here? Oh, they never give the Amazon never 1987. So that book was written as a direct response to the creationist trial in Arkansas in whatever year that was, some years before the book. And in that creationist trial in Arkansas, the creationism was said to be a religion and evolution a science, and therefore, because of the Establishment Clause of the Constitution, teaching creationism was illegal. And so they wrote this book to try to combat that. And so they created out of thin cloth, out of whole cloth, this idea of origin science versus operational or experimental science. They completely mangled the history and philosophy of science. They completely mangled the history of how we got here and what Karl Popper had said. And so everything in that book that flows from that is also mangled. And so when we look at the past, this idea that there's a difference between historical and operational science is false. I gave you a great example. I gave you a great example from plate tectonics. What did you not like about that example? What did you not like?
Well, I could do the same thing with that you're doing with the origin of life.
No,
You're giving good evidence for this event, and I could come and say, well, just because you found that magnetic strip doesn't mean that your explanation is correct. I
Well,
could maybe it was aliens came down and put that
well,
there and it had
that's
nothing to do.
true.
So that's the kind of stuff you're doing with the origin of life right now.
No,
It's
no. It's very
clear.
different. I'll show you. I'll say why it's different. It's because you make a prediction and then you go out and collect data to test whether your prediction is true. When the prediction was made, nobody knew if those magnetic stripes would be there. And it was a bizarre thing to predict. It wasn't expected. And so that's the difference. That's the key difference, is making a prediction and then going out and collecting data to see if your prediction is true. That is the key element of the scientific
Scientific
method.
method.
And that's very different from what you're talking about, is just looking at a bunch of experiments and saying they didn't work. That's not a prediction. It's not a
Okay,
simple
I'm
hypothesis.
making a prediction. Life cannot come about by natural processes.
Okay, prove it.
Let me go do a literature review. Let me find out if it's a good hypothesis.
That's
Oh,
not the way
wow.
to do it.
Every single experiment is on my side right now. Wow, I have a good reason to think that hypothesis. Now let me go test it. Now I run the test. I find the same thing. Hey, maybe that's the conclusion I should come to.
Your internet connection is bad, or mine is.
Good. Okay.
You're frozen.
Oh, how's that?
That's better. So that is very, very different, because when they made a prediction about magnetic stripes, it was a very specific prediction, and they went out and collected new data to see if that prediction was true. So saying there's a bunch of failed experiments isn't anything. It's not part of the scientific method, and because you don't know what experiments in the future will be successful. So you have to go out, you have to make a very specific prediction, not saying that, we do a literature review and it shows that nobody's figured it out. That's not a prediction. A prediction is, we'll go out and we'll see this certain observation, and if we don't find that observation, it means you have to falsify your hypothesis. That's the way it works. Now, what you said is actually very true, that finding the results of the prediction is true doesn't mean your hypothesis is true. It doesn't. But if you make prediction after prediction after prediction and they all are true, then you say the hypothesis is very robust, that you start to have a lot of confidence that it's true. And with plate tectonics, there have been so many predictions that have been made that we have a very high degree of confidence that it is true and that the Earth is evolving in that way, because there are so many predictions that have been made. So that's very different than what you're doing, because you're not making predictions and going out and collecting new data to test whether that prediction is true. And saying nobody's
No.
discovered a way for this to happen isn't a prediction. It's not.
Well, it's more about what we know doesn't work. Okay, so it's more about what we know about reality. Like it's what are so okay. Let me give you this example. Let's say the plate tectonics thing. Let's say they made the prediction. They went out. They found the magnetic strips. Okay, or no, they didn't find it. Let's say they didn't find it. Okay, and then they made another prediction, and then they didn't find it. When does the hypothesis start to say, hey, maybe we should stop looking in this direction because
The very
we're
first
not
time.
fine? What?
The very first time. If they had not found the magnetic stripes, it would have meant that plate tectonics, if they were right about the Earth's magnetic field flipping, which there's tons of evidence that that is true, because we have stacked lavas on land where you can go and measure it and everybody agrees it flips. If those magnetic stripes had not been there, absolutely that would have been the nail in the coffin right then. It wouldn't have been a series of steps. That would have been it. Now, humans are humans, and humans get emotionally attached to their theories, and there probably would have been a lot of gnashing of teeth and consternation, but ultimately it would have failed. And there have been a lot of predictions that have failed, where they went out and made a prediction and collected data, and it was wrong. And so that was, and in fact, the opposite prediction was also made that if the continents had always been static, then there wouldn't be magnetic stripes. And it's not just that you would fail to find them, it's that they would not be there. And so that prediction was falsified. And so that meant that this gets into the weeds, but there's a whole other theory called geosynclines that was rejected. And so, yeah, it just takes one, but it has to be a very robust prediction, and then that would force it to be rejected. Absolutely. Not a whole series, just one. Yeah, it would be rejected. It would have been, if those magnetic stripes had not been there, that would have been the end of plate tectonics. Now,
So
there's,
is there anything like that that you can think of for a particular theory of abiogenesis that could be rejected?
I don't know enough about chemistry to know how you would design it. You'd have to design some hypothesis about the steps that are needed for chemistry of life and proving that one of those steps couldn't happen. I'm a
Well, that gives look, I like that you use steps because this is an or the stairway to life, an
yeah.
origin of life reality check.
Who,
Okay.
who wrote that? I don't know those
This is
people.
Dr. Rob Stadler and Dr. Change Laura Tan. She's a
Doctor of what?
biochemist and Rob Stadler's a bioengineer.
Yeah.
So
What I've seen a lot of is when engineers dabble in evolution, they just constantly get it wrong. So I can't say anything specific about that book. I've ever read it. I think you're cherry picking the evidence because you're cherry picking the books that show what you like, and you're ignoring all the books that show what you don't like.
I read more books on the opposite side. I read more books on the evolution side than I do on
Yeah.
my own side. Okay. So I'm not cherry picking. I'm actually the books that are about evolution, they contribute more to my rejection of evolution because when the admissions come from the side that believes it, right? That's stronger than when it comes from the creationist side who wants to reject it.
Yeah, well, I'll have to stick to. I'm trying to stick in my lane, and I'm going a little bit outside, which makes me a little uncomfortable. As you know, I'm a geologist and a stratigrapher and a paleontologist, and what I've seen repeatedly is that when creationists talk about areas I know well, they are 100% false. There's so many false statements that come out of their mouths that it gives me very low confidence that what they're saying outside of my expertise is correct. And
Well, I
so,
understand that's an issue that you have, and I'm not knowledgeable enough in geology to be able to evaluate your statement, right? So, you know,
well,
I
I can
that
give you as many examples as you like, but you don't like it when I mention people's names.
Yeah, but well, what I would like you to do, and this is what I've asked you to do, and so far, every time you come on here and you just want to talk bad about creationists, but what I would like you to do is bring specific evidence. Bring me something that I can actually look at, read, see what the evidence you're presenting, not just take your word for it, because I'm a skeptical person. I don't take people's word for it, even on my own side.
Okay,
Okay.
here's a specific observation that if let me give me a couple months, and so now that's going to go into January to bring together a presentation. But here's one specific thing that I think is very tough if evolution isn't true, and that is the distribution of animals through time. So if you look at, there's a lot of evidence for beautiful preservation of river systems in the Precambrian. We've got river channels, river bars. We've got all sorts of sedimentary structures that, require subaerial exposure, and we've got soils, no life, of course. And so then the question is, why is there in the entire Precambrian, not a single tooth, not a single footprint, not a single bone? And we have all these beautiful river systems. So what kind of river system doesn't have life associated with it? And the only answer we have, and this is more of a forensic analysis. So, looking at the past is a combination of hypothesis testing and forensic analysis. That part is true, but the hypothesis testing is critical. Is the only type of river system that could exist, and we see this all over the world, is a river system that was on a planet that didn't have terrestrial life. And we see these river systems all over the world in the Precambrian, and none of them have life associated with them. In fact, the first life we see associated with river systems isn't until the Silurian or Devonian, probably middle Silurian, I would guess. And then from that time afterwards, all the river systems are packed with life. I mean, just packed. And to add one more kind of step to that puzzle, if we look at the, say, Silurian or Ordovician or Silurian, we see widespread marine limestone that covered all of North America that where we have the Ordovician Silurian preserve. I mean, there's areas of uplift today where we don't have Silurian Ordovician, where it's probably been removed, but everywhere else it was covered. So if you think that the dinosaurs and the pelycosaurs were all alive at that time, where were they? You know how, because every place where we see dinosaur footprints today, if you go down, there's marine limestones that were hundreds of miles in every direction. And so, where were the dinosaurs? How did they get there? And they not only had to get there, they had to get there while they were alive, to leave footprints, to leave nests. And if you go back a little bit earlier in the pelycosaurs left their footprints. We've got lots of evidence they were walking around. And then how did they get there? And how did they get there without any mammals? Because the pelycosaurs are never mixed with dinosaurs or mammals. And yet, when we look at the distribution of marine limestones that are older, it's marine conditions for hundreds of miles in every direction. So there's just no logical way to get them there without evolution and long time. Because otherwise, you'd have to have them like floating in somehow. I mean, especially if you're going to apply the 1 year flood hypothesis strictly, it just doesn't work.
Well, I want to go back to what you said about the river channels with no life.
Sure.
I'm wondering, could that be underground springs? Because I
Yeah.
mean, right now we have that. Why not?
Well, underground springs don't create deposits that look like river channels. I mean, it's just the sedimentology
What's the
isn't.
difference in the deposits?
Well, underground springs are coming up through cracks in the rock. They don't form laterally extensive deposits. They don't form the geometries and the sedimentary structures. Like I'll just give you, there's I teach courses on this for a living, and I spend a week in an oil company teaching people how to do this, and I just cover the bare minimum in a week. You just can't get into the details. But for example, a lot of these river systems, one of the sedimentary structures we see is raindrop imprints, where you see a, um, a strata, and then you see all the little craters that are made by raindrop imprints, and mud cracks, and other examples where they can only be created by subaerial processes. A spring can't do that. So this is, I'm not trying to insult you because I know you're not, you don't have expertise in this area, but it's just there's nothing remotely possible about what you said about a spring doing this.
Okay, well, I mean, that's just the best. That's the best suggestion that I can give
I
right
love
now.
that you're thinking, outside the box and trying to come up with explanations. I think that's awesome.
And
But
mhm.
right now, for example, I've seen creationists say, "Well, all the Precambrian is just all deep marine, so that's why we don't see rabbits." But it's not. We see the entire diversity of depositional systems in the Precambrian that we see today, except without life. So we see sand dunes, we see glaciers, evidence of glaciers. We don't see the glaciers themselves; they melted, but we see evidence of glaciers, and we see rivers, different kinds of river systems. We see lakes and oceans, but no, in the oceans there's life, but it's all except for the Lake Precambrian, it's all stromatolites. And so the
Well,
lake.
I find getting an answer on this very challenging. And right now, I am looking into this because Grayson said he challenged me on the overall ordering of the fossil record. And I'm never letting somebody make that broad of a challenge again. Like from now on, it has to be something narrow because this, I'm
I'll
finding
give
it.
you, I'll give, I'll give you. Sorry for interrupting. I'll give you a very specific challenge. That if you look at, and I can put together some graphics on this. I don't have them right now, but if you look at just river deposits, that's all we'll look at. Just river deposits through time. In the Precambrian, the Cambrian, and the Ordovician, there is no hint of life. In the Silurian, you get a few little, a few little, not arachnids, yeah, arachnids, and some few little herbaceous herb type things. And then by the time you get to the Devonian, you get huge forests with reptiles, but no mammals, no angiosperms. By the time you get to the late Carboniferous, that is the late Paleozoic, you get so that's the Mississippi and Pennsylvania Permian. You get the pelycosaurs, which are those finback reptiles. You get a lot of different reptiles. You get a lot of different kinds of plants. Um, I'm not cherry picking the evidence. I'm just stating what the evidence is. So you get a lot of different kinds of plants, but again, no angiosperms and not a hint of mammals, not a hint of dinosaurs. And then when you get up into the Mesozoic, you get lots of dinosaurs, but no placental mammals. And then when you get beyond that, you get lots of placental mammals. And in the late Mesozoic, you get some angiosperms. So there's a very specific order of life just looking at what's associated with river deposits, nothing else. So we're not looking at all of the evolution of life. It's just that. And so, the transitional forms is a problem, but it's the lack of transitional forms isn't evidence of anything. And there are some great transitional forms, especially the transition from. Um, I need to look something up just so I just don't say.
Okay,
I'm just
great.
giving.
So,
You
good to see you, Titan Uranus. Good to see you on this channel. Haven't seen him on this channel before, so glad you're here.
Oh, I'm looking at eBay. I'm not looking on Google. Jeez. So let me try again. So there's a great so there's a great transition from what are called the therapsids, which are the mammal-like reptiles. This includes the pelycosaurs, those big finback reptiles. Maybe you don't know what they are, but if you saw one, you definitely recognize it.
Yes.
And then the transition from there into mammals is just beautiful. And so that's a great transition. And the therapsid reptiles and mammals form one group of reptiles, and I always get them confused. What's an anapsid, what's a diapsid? Anyways, but there's one group of tetrapods that are the therapsid reptiles going into mammals, and then another group of tetrapods, which are the reptiles and birds and dinosaurs, and therefore they have two different types of skulls, completely different types of skulls. So and so that those transitions work very well.
What are the transitions that don't work well?
Um, the the first angiosperm, I don't think there's a good transition there. The first coccolith is a microfossil. That transition doesn't work well. I also think all the transitions we see in biostratigraphy are arguments for evolution. For example, you can take one of the groups that is used a lot for biostratigraphy is called coccoliths, which is a single-celled algae that has these calcite plates. They're very, very tiny, but they're useful in biostratigraphy because they survive the drilling process of oil wells, so you can collect samples and use them for biostratigraphy. We did that a lot in the oil industry, still do. And you can look at successions that are hundreds of kilometers apart, and the succession of species is identical. They're never out of order. In fact, you can go across the Atlantic and look at succession of coccolith species in Angola, and they're the same as here. And so how does that happen? It's not sorting, it's not hydrologic. The only explanation I know of is, and this is forensic analysis, but still, the only explanation I know of is a long period of time in evolution. And I don't know of any other way you could do that. And, we know this works because there's tons of evidence that you get the same exact succession. And it's not sedimental logic because they're independent of the succession of different types of sediment, like mud versus sand versus gravel. It doesn't matter. You get the same succession. You do get missing zones, but you never get out of order zones. So when you start looking at all of that kind of evidence, and it's not just coccoliths, it's a whole series of microfossils where this has been done repeatedly. And so that like biome hypothesis where you're gradually flooding higher biomes, that falls apart very quickly. And so
Well,
there,
does it? Because I was thinking, like, right now, if like all the algae alive today got buried, would it all be in similar layers?
um, well, there's algae that is bigger and smaller, but there's no reason why that when you look at just the coccoliths, why they would be always in the same order, and they are. And there's no reason for that. And how do you get the same order in places as far apart as, say, 10,000 kilometers? How does that happen?
I don't know, but that brings me to my other question because I've been learning a bit about mega sequences,
Oh, yeah,
right? Like,
I know what they are.
so what is your understanding of how mega sequences came about?
So the concept of mega sequence, it kind of irks me that creationists use that term. It's not a wrong term, and it's used in geology sometimes. But a better term is called the sloth sequence. And I still teach this. I taught a course at a oil company a few months ago, and I still teach this. And so, what Sloss did, and he published this in 1964, is that there are, when you look at North America, he was just looking at North America, and now we know a lot more about it. But he discovered that there were unconformities that separated these large packages of rock. And so, and these unconformities, if you look at the biostratigraphy, the amount of missing time gets bigger as you go across the continent. So if you want me to show you a graphic, I've got one.
Sure. Yeah.
Yeah, since I didn't know this was going to come up, I have to look for it, and of course, I'm using you as an excuse to procrastinate on editing a paper I'm working on. So, thank
I
you,
think it's a worthy distraction.
thank you for that. So let me just give me. I just have to go into my lectures and find the lectures from this one. There it is.
Andrew says mega sequences usually represent sequences of transgressions and regressions, if I recall. I don't know what that means.
That is absolutely correct. And let me see if I can find. I'm just looking for the right.
Frank says the global flood over a brief period of time would have similar fossil layers over large continent wide areas of land, as each tsunami dumped its collection of creations under sediment on the land.
Well, tsunamis have very specific sedimentology, which we don't observe, so that's easy to disprove, and it's actually not correct. So you'd get, for example, the very first things that would be swept up in modern coastlines would be angiosperms, such as grasses and mangroves, and we don't see those until very late in the succession. They should be very early in the succession. Um, it really pisses me off that I can't. There it is.
Wolfgang says, where you see a cross, you will find evil in disguise.
Well, that's.
Yes,
I'm
I
sorry.
am disguise.
Okay.
Actually, I'm not trying to disguise my evil. I'm very aware of the evil that is in me, which is why I love my Jesus.
All
I
right. So
love my.
I've got the figure. I don't have a reference to it, but Can I share my screen?
Sure.
How do I share my screen?
Oh, you press that little button that has the computer screen on it right there, like at the bottom.
Yeah,
It
yeah, yeah.
has like a screen looking thing. And I wanted to ask you because, you seem to be willing to spend time doing this, and I honestly do not understand your motivation. So I've
I
been
will tell you
clear
my
about my
motivation.
motivation.
I'll tell you what my motivation is if you're curious.
Okay.
I love what I do for a job. I absolutely love it. I love it in a way that I can't explain logically. I've been fascinated with geology since I was a little kid, and I've collected rocks and fossils. And it just pisses me off to see people say things about geology that are blatantly false and convince people that they're correct because they have this air of authority. And I'm going to use somebody's name, I'm sorry, but an example is when Dr. Warner says there are no river channels in the rock record, he is lying. I don't know any other way to put it. And it just pisses me off to see so many examples of this. And that's my motivation, is to correct the record, to say,
Okay.
no, what people are saying about the rock record is not true. And I
Okay.
could give you countless examples. So
Well,
that's my
I can
motivation.
tell
I get a
you.
little bit too excited, and I apologize for that.
Well, this is what I would like to see because uh you have a lot of accusations against Dr. Warner, and he actually writes in his books. He says, "Please, if anything is scientifically wrong with what I have presented here, please write to me. I don't want to be putting out false information." So he has made an open request in writing to please correct him if he's wrong. So I would love to see that, him actually to hear from you and be able to evaluate what you're saying.
Sure. I mean, yeah, it's just that, and I'm not exaggerating, when it comes to, he says some things about paleontology, about frauds and stuff that are correct. A lot of what he says about frauds are wrong. Everything he has said about stratigraphy, from what I've heard, is wrong. It's not just a little bit, it's everything. And so that's why I have a hard time. And it's not just him. I'm picking on him because he happened to talk about something that I work on. But, especially in standing for the truth, everything they say about geology is almost 100% wrong. So it's not like it's one little thing here and one little thing there. It's everything. When they describe the fossil record, they're cherry picking the results so badly that it gives a false impression. When they describe stratigraphy and coal and all sorts of other things, it gives a false impression of what reality is, because a lot of times the statements they're making are true, but cherry pick so badly as they're picking the one little example. Like, I'll give you just one example that everybody uses. They show all this rapid deposition, and they'll show like an upright fossil tree, and they'll say, and there's hundreds of videos that show this. They'll say, oh, those silly geologists, they think it took millions of years to bury this tree. Well, no, nobody thinks that. Nobody thinks that. Nobody has ever thought that. This is something they're completely fabricating. All the evidence for rapid deposition is absolutely true, but it's also extremely rare that the vast majority of beds show evidence of very slow deposition. And they're cherry picking the evidence, like showing the fossil of the fish eating another fish that died while it was eating or something. But those, although you can go to museums and the museums are filled with those examples, they're still exceedingly rare, because nobody would go to a museum that was filled with bits and pieces of bones. That wouldn't excite anybody, even though that's by far the most common fossil. It's just like going to a museum of gemstones like the Smithsonian. The most common diamond are these industrial diamonds that look like nothing. Nobody's going to go to a museum filled with those, but those are the most common diamonds. What you want to see are the exceptional ones. And you see a museum filled with these exceptional fossils and you think they're common, but they're not. They represent a very tiny fraction of the total outcrop area in, say, North America. And so that's what motivates me. It's trying to set the record straight about what the evidence actually is. The vast majority of fossils, by like thousands to one, is that they're poorly preserved and they show evidence of very slow deposition. That's the reality. And there are evidences of rapid deposition. All of them were discovered by mainstream geologists first, then used by creationists who claim that the mainstream geologists are ignoring them. But it's not true.
Okay. Okay, now this is I'm glad you're bringing this up because I do want to hear what is the evidence for slow deposition, because I can tell you in my experience, just in the places that I've been, and I've done a lot of road trips in multiple countries, driven, like, hiked, looked around at stuff, and everywhere I go, I see evidence of massive deposition and lots of layers that don't seem to have erosion between them, and lots of things that tell me that, hey, this could be signs of a global flood. So, what is your evidence that these things were very slowly deposited over millions of years, and that that's like what characterizes the rock record?
Well, first, do you see my screen? I'm not sure.
Yes,
I shared
sorry.
my screen. Yes. Okay. So you asked about mega sequences. So let me answer that question first and then
Okay.
answer your question. So this is a time stratigraphy diagram. So the way to read this is the vertical column is time. Whether you believe the millions of years or not really isn't relevant. And I've ordered it, Cambrian, Ordovician, Silurian, Devonian, and all that. And then
Awesome.
the um, the gray area, I said something wrong a few minutes ago, but I'll correct it now. The gray area is where there's missing rocks. So, for example, this is going, and this is not a complete diagram. I didn't finish it yet, and I can't find my finished version. So, on the left is Western North America, and on the east is Eastern North America. So, we're kind of looking like a cross section through the stratigraphic column from the middle of the continent out to the extremities of the continent.
Okay.
And so all the gray area is where there's missing time. So if you go to the middle of the continent, there's no record like in, say, in where I used to live in Lawrence, Kansas. There's no record in Lawrence, Kansas from about the middle Permian, Triassic, and there's no Jurassic, and then it's actually no Cretaceous either. So there's a huge gap. But if you go west, where close to where you live, there's a beautiful record of all of those periods. And so what this is showing is a series of of successions that are separated by unformed. So if you were to look at the rock outcrop here, these rocks would be on top of those rocks with an erosional unconformity between them. But the thing is that erosional unconformity may not be very profound looking at it in one outcrop. It may just look like a flat surface. But we know biostratigraphically and we know regionally there's a lot of erosion on that surface. And so these are the mega sequences. And so what Sloss did in the 1960s is said each of these represents a transgression and regression. So a transgression is when sea level goes up, and a regression is when sea level goes down. So when sea level goes up, the continent is buried under marine conditions, and when sea level goes down, the continent is exposed. So, for example, in the Silurian, this is all limestone here, or almost all limestone. So there's these Silurian limestones that just go right across the continent. And so what that means, now this is a two-dimensional representation of a three-dimensional problem, so it's more complex than that. And so what that means is that during the Silurian, most, not all, but most of North America was submerged. So if you believe in Noah's flood in a short time period, where were the dinosaurs at that time? How did they get back to Utah and Colorado to leave their footprints and their egg nests? Where were they? Were they swimming? Were they all just gulping for air and all of them together without any modern animals associated with them? It just doesn't make sense. So that's what these mega sequences are. And most geologists call them Sloss sequences because Sloss was the guy who started this. And then this
Okay.
went on, and and there was a whole science of stratigraphy that was developed at the oil company I worked for, Exxon, called sequence stratigraphy. And the reason they called it sequence stratigraphy is because Sloss called these things sequences. And so there's unconformities at a variety of scales going down to very small scales. And there's lots of evidence of erosion. But, one example, well, I used to, when I lived in Houston, we had friends in Dallas, so we'd drive to Dallas occasionally. It's about a 5 hour drive. And this land surface has been eroding for thousands of years. And yet it's not like there's deep canyons there. The erosional surfaces go down at fractions of a degree and then come up at fractions of a degree. They're very subtle. So if you were to imagine layering a big marine transgression, you layered rocks, layered sediments on top of it, and then looked at a cross section of a road cut, you wouldn't see any obvious erosion. You'd have to look at it regionally to see that. But I'll show you an example of erosion because I happen to have shared this slide today. So I happen to have it hot linked on my desktop. So here's an example of a river valley in Kansas. This is a Kansas outcrop. This is based on some work that I did a long time ago. I put a little pelicosaur there for fun. But let's look at this. So let me explain. Let me zoom in.
Wait, I don't see a pelicosaur. Are we looking at I don't think you didn't change the slide for me.
I did not. Let me, I'm going to do it again. I shared a yeah, I need to share an entire screen. There we go.
Okay.
Yeah, I shared the wrong thing. I shared a window, not a screen. So here's a picture I took in, I don't know, 1983 or something. No, it would have been 1988, 1989. So there's my car for scale. So here's the pelicosaur. Let me move the pelicosaur out of the way. So this is limestone here. And this is limestone here, the marine limestone that goes all the way across the top. Okay, can you see this bed of marine limestone? So there's the bottom of the limestone. There's the top of the limestone. Do you see that where I'm pointing?
Yes.
Okay. And so here's a schematic example of what that system looks like. So we drilled a series of cores. So here's the limestone going across the top. These are the limestones on the bottom, and here's the erosional surface that cuts it out. And so here's 5 meters, which is about 15 feet, give or take. And so this is 10 meters deep. So that's 30 feet of erosion. And it's cutting through all these limestones. Okay, and so this is a valley. There's a valley. That's the erosion, and we got it. Here's the valley edge right there. My staff is resting on. Now this has all been quarried out. All this shale has been quarried out because it has lots of fossils in it. So they quarried it for the fossils. And so here's a core that shows. I'm going to put my fun little pelicosaur down. The pelicosaurs are what they're excavating out of here. So here's a core that shows all these limestone clasts. And those limestone clasts were eroded from these limestones at the edge of the valley. And then, if you look at what's in the valley, it's not just these limestone clasts. So can you see these clasts? Like there's one right there, and there's one right there, and then there's a little tiny one right there. I mean, this is just like a gravel. It's limestone gravel that has all been eroded from the sides of the valley. And then here's, footprints. So we've got footprints of the animals that were living there. We've got lots of charcoal. There's lots of conifers. But importantly, what's not here is there's no angiosperms. And this has been looked at both for the palynology and for the macrofossils. And these are all photos that I've taken. These are specimens that I collected. And then here's raindrop imprints at the bottom here. So, the raindrop imprints are critical because it shows that the area was severely exposed along with the footprints. I mean, maybe the footprints were under, this much water, but not anything more than that. Uh,
Now, is this the I mean, I don't know because I haven't even looked into like what the creationist view of this is, but I mean, could this have been ground that was exposed and had footprints and raindrops on it and then later got buried in flood sediments?
that's exactly what it is, but there's flood sediments before it too. So these limestones, let's go back to the cross section. These limestones here, the Stoner, Capitan, Spring Hill, these limestones go for hundreds of miles. So that means the entire area was completely submerged. Then sea level, and it had to be submerged because these are all marine, filled with marine fossils, right? So they're marine standard marine limestones. Then sea level went down, and this valley was eroded through solid rock, right? This was the limestones were already limestone at that point. We've got the bits and pieces. I'm pointing to the screen, which you can't see. We've got the bits and pieces of the limestone right there. So we've got all that limestone gravel. There's actually weathering on this surface coming down. There's weathering there that is not modern weathering, but is weathering from the time when this valley was exposed. We've got the raindrop imprints and the footprints to show that it was severely exposed. Lateral to this are soils. It is a particular type of soil called a vertisol that takes hundreds to thousands of years to form. We've got all these plants like conifers that, for all, we don't see them upright. We don't see upright trees, but, there's just so much vegetation here. They're probably living nearby. And, if you look at some of the conifers, not all of them, but many of the conifers, are just in pristine condition. I mean, just every little conifer needle is preserved. And so here's the challenge, and this is just one example, is since this area was completely submerged, and if you go back to the Silurian, almost all of North America was submerged. If you believe in a 1 year Noah's flood, where did these animals come from? And it's not just one type of reptile. They're not really reptiles, they're theropsids. Where did they all come from? Where did they come from? And there's insects in here, and associated with other similar deposits to this, there's lots of insects. And we've got, how do we know soils take? That's a really good question. So it's not just that we find soils in the ancient, it's we find the same kinds of soils we see forming today. And so there's places where like land has been produced from, say, a river bar that has been converted to a soil, and we know from historical records when that river bar was created, when the river moved to a new location. So we have that. It may go back to Roman times, and so we have a 2,000-year history. And so we know from modern systems how long it takes these soils to form. And vertisol, I like using this as an example because it has specific features that require wetting and drying of the soil. And so in order to create the features of a vertisol, you have to wet and dry the soil thousands of times. You can't just do it quickly. There's no process to do it quickly. And it's not just wetting and drying of the soil, it's that there's chemical alterations where you're dissolving minerals from the top of the soil and depositing them at the bottom of the soil. There's all sorts of complicated features that you find in these things that they cannot form quickly. They can't. There's just no physical process to do it. And so when you combine it with all the evidence, you have to say, well, how did the pelycosaurs get here without any dinosaurs or any mammals? Like, where did they come from? Because there's marine, below this, there's marine rocks for hundreds of miles in every direction.
Okay, now if I do what you were doing earlier and I say, how do we know that we just haven't found a way for those to form more quickly?
No, it's more complicated than that because we can measure how long it takes for clay to dry. I mean, there's just a physical process there that has to happen. These soils are maybe 1 to 2 meters thick, and so it takes, for them to dry. No matter how hot it is, it's still going to take days. Once they're thoroughly wet, it's going to take days for them to dry. and then they'd have to get wet again, and then it would take more days for them to dry. And what happens is you've got the chemical alterations, and you've got these features created called slickensides that get organized into these patterns, and it takes thousands of cycles of that, of wetting and drying. And so, and so there's just no way. It's not just that we don't know of a process, it's there's no way to speed it up. You can't force it to dry faster than it's, I mean, if you had, I don't
And
know,
you think
it's
there's no
amazing.
possible way we could in the future
No,
find. Okay,
no,
so
because there's,
wait a minute. Why are you so confident
because
about that?
here we
And
know
wait,
that,
let me finish my point. Let me
I
finish
know what
my
you're going to
point.
say.
You've been talking for a long time. Why are you so confident about that? But when I tell you these types of things about the origin of life, that the chemicals don't come together. It's about what we do know. They don't come together. It's about what we do know. The information does not form itself. Why is this? Why won't you accept that? And why do you say, oh, no, but we could still find possibly a way in the future? I'm being very scientific about this. But do you see the double standard you're having?
No, because here we know the physical processes by which clays dry. It's not that there's no known way to get it to happen fast, is that we know enough to know it cannot happen fast. It takes time to dry clay, and these soils are in clays. And so you have to, and it takes time to dissolve the minerals, and there's no way, there's no physical process by which you would speed that up. And so, and we know it, you have to go through thousands of these cycles of wetting and drying to form these very specific features that we see. Now, when you
Right.
say we can't make those chemicals, maybe if you ran the experiment for a million years, you would make the chemicals. You don't know. That's a very different point because you don't know that it wouldn't happen. Whereas here we do know that it can't happen fast.
But the chemistry does not change. So what you need is for chemistry to change.
I don't agree. But
Okay.
I
Well,
want to
you
tell
haven't looked
you,
into it, right? You
well,
haven't looked into it.
fair enough. And I'm sticking
Okay.
to what I can say here that all the evidence is that this type of a feature took, at a bare minimum, thousands of years to form, and yet we've got dozens of these features just in the Pennsylvania. And so it forces a long period of time.
Okay. Well, I appreciate you sharing that. And I will take into consideration what you're saying about these geological formations. Grayson's waiting backstage, but I did want to say, first of all, I do think you're having a double standard with what your methodology, by holding out hope in spite of scientific observations in one area, and in another area asserting that no, we can't possibly find a mechanism, even though the scientific evidence, it, in regard to the chemistry for origin of life, is very solid, extremely solid. So I do challenge you to look into that. But there was another question I wanted to add. That What was the question I was trying to ask you? And you were like, let me do this first.
Evidence
And
for slow deposition.
the what?
Evidence for slow deposition.
Yes.
Okay, there's several lines of evidence for slow deposition. One of my favorites is bioturbation. Especially in shales or mudstones, fine-grained rocks. I've got a lot of experience in this. I don't know anybody that's created a database. There's that one study you pointed me to that's deeply flawed, but there's just vast amounts of bioturbation. Now you say that you've seen lots of beds that are preserved, and most bioturbation barely goes down a meter. So if the bed is thicker than a meter and the bed is deposited rapidly, and then there's say 1,000 years after that bed where there's no deposition, the bed will never be destroyed because the bioturbators just don't go down that deep. And so you have to look at not just the amount of bioturbation, but how deep the organisms are bioturbating. And the further back in time you go, the shallower is the level of bioturbation. So in the Precambrian, there's essentially no bioturbation until the very, very latest Precambrian. And then by the time you get to the Cambrian, Ordovician, Silurian, the amount of bioturbation gradually increases. By the time you get to the Pennsylvanian, it's pretty pervasive, and the Cretaceous is pervasive. And by the time you get, say, to the to soils in the Jurassic, you've got incredible amounts of insect bioturbation where the insects have completely churned the muds, and you can show pretty clearly that beds have been destroyed, but thin beds. You know, the thicker beds, if the bed is 3 meters thick, it won't ever get destroyed by bioturbation except for the top bed. And you do see a lot of that. You see a lot of beds where the bottom is pristine and the top is thoroughly churned. And so when you look at all the evidence for bioturbation, it really it's not I don't it's not possible for the Noah's flood to be true because you need such incredible rates of deposition that you'd need some bio. And here I'm using a uniformitarian approach, saying we can look at rates of bioturbation today and project them back in time, but I don't know how you change that. Now I will make one caveat to that, and that is limestone. Commonly, when carbonate is deposited, it gets turned into limestone so fast that there's just not time for it to be turned before it's turned to limestone. That's not always true, but it's sometimes true.
Okay. Well, I mean, I'm not sure about the bioturbation thing because when I talked to you about this several months ago, you said bioturbation will destroy layers, right? Like there wouldn't be layers if
Yes.
it and okay. So when I
Thin
paid
layer, thin layer,
attention,
thin layer.
when I've been out and about and seeing all these rock layers in Utah, I have like there's just everywhere I go has layer upon layer, and it does not look like there's bioturbation because you can clearly see the layer. You see like one, like seriously, it's like red, then white, and it's like you like see a clear layer and it's flat on top of the other one, and there's no bioturbation.
Well,
And I've seen that in so many places.
next time you see that, take a picture and send it to me. You've got my email. Just take a picture with your phone and send it to me with a scale in it. Put something in there for
Okay,
scale, like a penknife or a coin, anything for
got
scale.
it.
And also get an app called Rockd, ROCKD. I think it's free or it's a couple bucks. And that'll also, if you've got cell phone service, that'll tell you what formation you're looking at. So then you
Oh,
can tell
nice.
me the formation name and a photo, and I'd be happy to interpret it.
Thank you. I appreciate that. Well, I did think about sending you pictures, but I was like, ah, I'm not going to bother him. But now I
No, do
will.
it. Do
So
it. But
thank
then
you.
put something, be sure to put something in the photo for scale. Even if you're
Okay.
just like sticking your hand up against the outcrop and taking a picture with your hand if you don't have anything else. But put something in
Okay.
there for scale. Otherwise, it's very hard to interpret.
Okay. Got
All
it.
right, I've
Well,
had
thank
enough.
you for your
Enough.
time.
Enough. I need to get back to work.
All right. I hope it goes well. Thanks for coming
Okay,
on.
thanks.
Hey, Grayson.
Hey, Rebecca, long time no see.
Yeah. What do you got for me? I'm
Oh, I
expecting
mean,
another doozy. I'm working on your evidence. It's pending. Okay. So
well, yeah.
it
So I
might
was
be a
just gonna
little
say,
while.
like, I mean, I already put forward evidence last week. I haven't gotten like there hasn't been an answer to the challenge yet from the creationist camp, from you or from others. So right now, I mean, I think that evidence stands and is a defeater for creationism and is strong evidence for evolution. But I really wanted to come on and talk more about the kind of arguments that you were presenting against evolution, and I wanted to give you some pushback about certain of like the probability arguments or
Okay. Cool.
the things that you were saying towards the beginning.
Sounds good. But let me just respond to what you said about the evidence stands. First, like if it's going to be considered evidence, I have to actually see the evidence you brought. And I'm not going to let people do this in the future, but I'm not going to make you go back and like present specific evidence. But like, so I don't think it can stand as evidence because right now you've just told me your version of how you didn't present a paper, you didn't present a picture, you didn't present of like what you're showing. So I can't count it as evidence when I actually don't know if what you said is correct. So part of what I'm doing is trying to figure out if what you said is correct. And so because it's such a big challenge, and for those who are watching, what Grayson challenged me with is the overall ordering of the fossil record he thinks supports evolution, which, I think you acknowledge that there's some problems with the evolutionary story with the lack of transitional forms.
I don't
Okay.
acknowledge that
Okay.
as being a
All right.
problem.
Well. Okay. Well, I presented that as contrary evidence, but
And
he's
then I
talking
shot it
about.
down and showed why it wasn't.
Okay. Well, we won't get it. We'll that'll be pending for the future. Okay. So I'm working on that, but it will be a while before I can answer because this is like a huge question. We're talking about like the sediments of the entire earth, right? And
Mhm.
like what they actually show. So it's
Yeah,
gonna be a while before
to
that
my
can happen.
knowledge, all of the major creationist organizations acknowledge that there is an order to the fossil record. I'm not sure. I'm not aware of literally anything like any shred of evidence going against that. You brought up the pollen thing, but like Howard did a good job of explaining why those pollens were obviously not fossils like from that layer. Um, so yeah, even the create like AIG, ICR, the Discovery Institute, I mean, they all acknowledge that there's an order to the fossil record. They all try to explain it, but their explanations all fail. So that's I mean, everybody acknowledges that there is an order to this thing. I mean, I myself have found dinosaur fossils in the Morrison Formation. There's a video of me finding them like on my channel. I didn't find anything in that layer that shouldn't be in that layer according to our current consensus understanding. So like there's not a mixing. I mean, these things are ordered by species. I mean, I don't know. You can try to push against that, but I mean, you'd be going against all of the evidence that we've ever gathered in paleontology and geology.
But remember, I'm not challenging that there's an ordering. What I'm not sure about is that the ordering actually supports the evolutionary story. So,
I don't even know how you could even I don't even know how you would follow through with that because it doesn't really make any sense how it wouldn't. But okay, if you can find some way that the ordering is incongruous with the evolutionary paradigm, then I would be all ears. I would just
okay.
be very surprised if you could find evidence of that. So
Okay.
my
Cool.
main issue, right, whenever creationists or anybody talks about, oh, it's so impossibly improbable for life to form from non-life, the main issue that I have with that is, would you acknowledge that in order to calculate the probability of something, you need to know the mechanism? If you don't know the mechanism, you cannot calculate any probability. Do you acknowledge that?
Well, you would need to know, I mean, a proposed mechanism, right? Like you would have to, you might not know an exact mechanism, but if you have a proposed mechanism, you can
That's what I
calculate it.
mean. Like
Yeah.
a proposed mechanism would be the same for this case because you'd be calculating the probability for that mechanism,
Right.
proposed or
Yes.
actual or whatever. You need to have some mechanism in order to
Yes.
calculate a probability. Like you can't only just look at the final product. Like if I have like an iPhone, what is the probability of this iPhone? You can't know that unless you know
Coming
the
about by
mechanism.
natural processes?
No,
Very
exactly,
simple.
that's the thing, is that I didn't finish that because I didn't provide you a mechanism. Notice that.
Yes.
That's
Okay.
very important
Yeah.
because what is the
Okay.
probability of this iPhone is a nonsensical question to ask because I only have the final
Right.
product. So
Okay.
I could be asking, what's the probability that this came up from like a bunch of random rocks hitting each other?
Okay.
Or I could be asking, what's the probability that Apple
Right.
designed this product?
Okay.
But without knowing the mechanism, you cannot just look at the final product and say, well, what's the probability? So that's the
Okay.
issue with all of these arguments about saying that this is improbable because we don't have even a proposed mechanism for abiogenesis. There is no possible way to attach probabilities to this process because we don't know the process yet. So every single time that anyone tries to provide a probability, it's in error because they're only looking at the final product. And there is a mechanism. Anytime anybody gives you a probability, they are tacitly assuming a mechanism. They're just not telling you what mechanism that they're assuming. If they're looking at a protein and saying, well, what's the probability that this protein formed? They are asserting a mechanism and they have no justification to do so. Normally, the mechanism is, well, what's the probability that just a bunch of random amino acids just happen to come together and collide in just the right way to get this protein in this exact sequence, which is a straw man because that's not what's being proposed in any of the hypotheses for
Okay.
abiogenesis. So it's like there is like there's no way to even calculate a probability if you don't have the mechanism.
Okay. So And Wesley asks, there is no natural process for the origin of life? Is that what you're saying? There's no mechanism?
There is no consensus mechanism, as in we don't currently have a theory for abiogenesis. We have a bunch of
Okay, so it's not
hypotheses.
scientific.
That is not the case either. You wouldn't say that quantum gravity or like consciousness, or you wouldn't say that any, or like for like example, like the Impemba effect of why water that's been heated cools more readily than water that hasn't been heated. We don't know why that happens, but you wouldn't say that it's not scientific just because we don't have a theory to explain it yet. We have hypotheses, but they're incomplete and there is no consensus theory. That doesn't mean that it's not scientific. That is literally the process of science. You come up with a hypothesis, and then you test it, and then you see the results, and eventually then that can get reified into a theory. But currently there is no theory of abiogenesis. We have multiple incomplete and competing hypotheses, but none of them fully explain it. Like we don't have like we have a theory of gravity or a theory of like atoms or a theory of evolution. We don't have a theory of abiogenesis. So you literally, there is no way to calculate probabilities if you don't have the mechanism. It's just erroneous to just look at the final results and say, what's the probability of my iPhone? Like you don't have a
Right,
process.
but the difference is that we can look at the processes, right, that chemistry and
Hmm.
physics allow for,
Hmm.
right? So we're looking at the processes that are, observable,
Hmm.
and that's what we're basing this on.
And we definitely have not checked out all of the different like conditions, like natural conditions for chemistry to occur at in a prebiotic earth. Like that is not even close to being exhausted experimentally. So
Which do you think well, you said we don't have a current hypothesis,
well, I said we don't
but
have a
then
current theory. That's different than a
okay.
hypothesis.
Okay. So what is the hypothesis that you think should be tested for the origin of life?
All of them, like metabolism first, RNA world, amyloid world. All of those I think are promising avenues to go down. Like like some of them are less than 10 years old. Like this is very new. We there are literally so many things about like protein and amyloid chemistry that we didn't know and had never been known before 5 to 10 years ago. Like there's no way that you can say, "Oh, well, we know all of chemistry. We know it all, and we know that none of it is possible to form abiogenesis in literally any conditions," because that's just not true. We're still learning new things in chemistry all the time.
Right, but does there ever come a point when something would raise your suspicion? Like, let me give you an example, like raise your suspicion that, hey, maybe something else is at work. Okay. So I'm going to give you an example from Stephen Meyer's book, Signature in the Cell. He says, when he's talking about the combinatorial math problem
Hmm.
of getting life to originate by natural processes.
Hmm. Yeah, he
Okay.
is one of the biggest ones that's doing this error of probability calculation.
Well, I don't know that it's an error. I think it's, using what we observe.
So what mechanism is he proposing when he does that calculation?
Well, w- based on, well, he's specifically talking about getting specified complex
Mhm.
information to arise
Via
by,
what mechanism, though? Because, like we said, in order to have a probability, and you said he did a probability calculation, it is necessarily the case that you need to have a mechanism in order to do that calculation. So he posited a mechanism. He didn't tell anyone what it was. He left that unsaid because it's very tricky. Because he wouldn't want to say what that mechanism is, because then it would be obvious that he's strawmanning the scientific position, or the naturalist position, rather.
now let me see. But I mean, so um I think he is saying what is commonly proposed, which is it happened, like it came about randomly, right? Like
Well,
it
you
came
see,
about.
it. that's not what's proposed, right? It's
Okay,
not just
what is
proposed that
proposed?
it's just random and that you just had like literally just random conditions that just poop, like a little proto cell formed.
But remember, we're talking, let's just narrow it down to information, because we could talk about an entire cell and then
Well,
we
wait,
have to come
before
up
we
with,
let me, I want to do this really quick. Like, if
okay.
I say, what is the probability that water turns into ice? And that's all the information I give you. Now, if it's 100 degrees, that probability is really low. But if it's below freezing, that probability is super high.
Right.
So the thing is that it depends on the conditions. The
Okay.
mechanism is going to be dependent on the conditions, and the probability is likewise going to be dependent on the conditions. I can't just say, well, the odds are 100% that water will turn into ice. It
What
depends on what temperature it is.
Yeah, and but what would be the conditions that you could propose for specified complex information coming about?
Well, you'd have to let me know what you mean by specified complex information, because like you could have crystals growing that have specified complex information. So there's never really been a good definition of that, and that isn't a scientific term. That's like a term that like Myers and like creationists, the ID camp has come up with this term that's not really recognized in science. But I would say that right now, that is what origin of life researchers are working on. Are what are these conditions? We're trying to figure that out. Right now, it looks like the most probable conditions are probably have to do with like um, deep sea hydrothermal vents, certain types of vents called like lost city vents. But again, that's just the leading hypothesis. There are other hypotheses too for like shallow pools, wet dry cycles. There's a number of different proposed conditions. Like I said, we have hypotheses, but they're all incomplete. We don't have a consensus theory for which to do any of these calculations.
Okay, what is it about anything thermal, wet, dry, or whatever, that you would propose could cause information to come about?
Well, again, information comes about with every single interaction. When two air
Okay.
molecules hit each other, there's
You're gonna
information.
make me you're gonna make me use their term over and over again. Specified complex information. There's a reason that they use this term, and it's to avoid the types of games that we're gonna play when we talk about crystals. Look, a
Okay.
crystal doesn't make you can't run your computer program on crystal information in crystals. Okay, so what we're talking about when we talk about the genetic code, we're talking about something that communicates specific complex information that and it is
I don't
very
think it
much like a
communicates.
computer. It doesn't communicate? Then how
No.
does the ribosome know what to build?
It doesn't know anything. It's not a thing that has knowledge.
Okay, well,
It's literally just a series of like reactions that are dictated by the electrostatics involved. It's like literally two puzzle pieces. They don't know how to fit together, but they literally just hit each other like this until they lock into place.
okay, I'm not saying the chemicals themselves know. Okay. But I am saying there is information being communicated in the genetic code. Do you deny that?
I don't think there's anything being communicated, because to me, my understanding of communication is from one sentient being to another sentient being. Like that's how communication works. So I don't know what it mean to be communicating from like a non-sentient being to another non-sentient being. I don't see how that's communication. Like
Okay, what about when you type something on a computer and it responds to what you're typing? Is that because that's the type of thing that we're talking about here, where it's something is responding, right?
but when I
We're
drop a
not
rock,
talking about sentient beings. Okay.
like when I drop a rock in a pond, the pond responds to the rock. Like these are just physical interactions that are dictated by the laws of physics. It's the same with the genetic code. Like these are molecules interacting in ways that are dictated by the laws of physics and chemistry. Like I think that it's sort of like a word game that people play in calling it like communication or these other things.
All right.
So
Well, then
I can give you a specific example.
are you saying there's no information in the genetic code?
Well, I think that there's information in literally every single particle of every atom in the universe.
Do you believe there is specified complex information in the genetic code?
What does you mean? What do you mean
Something
by specified?
different. What
What do you mean
what
by
I mean by
specified?
specified is that it's like okay, so like, complex information might be a string of letters
Hmm.
that's somebody's password that's a long string of letters. They don't communicate a meaning, but they are complex in that they reduce basically like they reduce your uncertainty about whether the computer should let someone into this, whatever they're trying to get into with their password. Okay, so that would be an example of complex information. But specified complex information is something that actually has a message in it, information in it. So that would be if you had a password and it had, um, I love my kids or something like that typed out. Okay.
Okay,
So
well,
that's
what
the type of
determines the sequence of the genetic code is its interaction with the environment and how fit it is. So, like, it's the interaction with the environment. For example, like if you just randomly generated a bunch of different amyloids of a bunch of different random sequences, like we're not even going to talk about DNA right now. We could do it with amyloids, with different sequences of amino acids as a type of protein. Like some of those are going to degenerate because they're less stable than others. Some of them are going to be more stable. So like then the sequence of amino acids is no longer random. There is a preference because of its interaction with the environment. So like the interaction with the environment causes this specified complex information. And
Okay,
it's
so
similarly like during evolution, like if you have like a bunch of random mutations, then the one that is fit versus the one that causes the organism to die, like there's going to be selection from the environment, and that's going to further specify that information.
okay, what would be fit about having a message that no one can read?
I don't know what you mean by that.
Okay. So what I mean by that
At
is
what step? Like at what step would there be somebody having a message that nobody can read? Like what would be
well,
that analogy?
because we're talking about the information that's in the genetic code,
Okay.
right? So you're saying it can come about because it's fit in its environment.
Hmm.
But I'm asking what's fit about having, a string of nucleotides that has a message, but there's no message receiver. What's fit about
Well,
that?
I don't understand this metaphor because in my mind, in the metaphor, the message receiver would be the environment, right? Because you have like, you're saying that the message is the sequence, so that sequence is going to interact with the environment in a way that is dependent on what that sequence is. So obviously, the environment is selecting based on the sequence. So in the analogy, the environment would be the message receiver.
Okay. Um what would the message be doing for the doing in order to be selected?
It would be impacting fitness. So basically, like even molecules, you can say that there's an analogy for fitness because some sequences are going to be more stable and some sequences are going to lead to like dead ends, basically, where the molecule just disintegrates. So stability is one of the very first things that would be environmentally selected for.
Okay, stability of the molecules themselves, but not having the information in them.
It depends on which hypothesis of abiogenesis, because some of them are metabolism first. So in that case, it would be stability for the entire like energy loop of like the proto metabolism. So like you'd have like a chemical reaction happening in a cycle, and like the stability of that cycle of energy flow would be what would be selected for. So it's not, it doesn't have to necessarily just be the molecule, but in like amyloid world, then it would be well selecting for the stability of the molecule of amyloid. So it depends on the hypothesis again.
Wesley's helping me out here. He says I should use this definition as a reference. Okay, thank you,
Okay.
Wesley. Okay, now I have to make sure I understand this. Semiotic information has an object, the reality, assign the carrier and the signified. Okay, I'm going to have to look this up later, okay? Because look, let's just go somewhere else because I feel like
Okay.
we're in fantasy land on abiogenesis here, okay? Let look, you know,
We don't currently have a consensus model for it, so like we just have hypotheses to be talking about, and you can say, well, here's some evidence that supports this hypothesis, here's some that supports this, but none of them is a complete story of, well, here's how you start with organic molecules, and here's what the first protocell would have been, and here's how it transitions to Luca. Like that is not fleshed out as a theory yet.
right. But do you believe that happened?
I think that there's good evidence. I think that I'm justified in thinking that abiogenesis happened naturalistically, yeah. But the evidence that I would
What's your
point to that
evidence?
would be
What's
more
your
so the fact that
justification?
the evidence that I would point to, like, and this is mechanism independent. So regardless of how abiogenesis happened, I think that we're reasonably justified in thinking that it did. Because we know, and I think we would both be able to agree that there's evidence, well, maybe not. I don't know about if you would agree or not, but I think at least within the scientific consensus, we would agree that there was a time before life. We have evidence of a time period before life. I would point to the cosmic microwave background as saying, well, there's definitely there's no life there because the whole universe was plasma. There weren't even atoms formed yet. So I would point to that as saying, well, we know that there was no life. We know that there is life now. We can see the fossil record that goes all the way back down, like through, again, the ordering of the fossil record with the very bottom being very simple single-celled organisms and stromatolites. And we can see even the window of where abiogenesis would have had to have happened around 4 billion years ago in the Hadean period. So like based on that, based on the fact that like again, that our question is whether this happened naturalistically or whether this abiogenesis happened with the intervention of like a supernatural being. And then I would point to the fact that the sum of total things that used to be attributed to supernatural beings has been getting less and less and less and less and less every year. It used to be that lightning was thought to be from supernatural beings. Now we know it happens naturalistically, diseases or epilepsy, stuff like that. So I'm just looking at the trend line and I'm extrapolating that it's more likely, and I would consider it justified, that the things that are attributed to supernatural agency are going to continue to diminish. I don't see any evidence that they are stabilizing or plateauing, and I don't think like I don't see any evidence to suggest that they would that trend would stop or reverse.
Would you like it to continue to go that way? Like, would you
Well,
prefer?
I would like
Would
it
you?
insofar as I would like to have an explanation for how these things happened. I mean, I'm very interested in the origin of life, so like, yeah, I would obviously before I die, I would love to know how it happened.
Cool. Would you be open to the possibility that God created?
Of course, I'm open to the possibility. I don't know how that would be demonstrated or what the evidence for that would even look like. Um, but of course, I'm open to the possibility, but I just don't consider it very likely based on all the evidence that I kind of went through. But I mean, that's a
Okay.
whole discussion about the existence of God and everything. That's a little bit different because you can believe like, and again, I don't, there are just plenty of theistic evolution people, or there are people that think that God started it with
Yes.
abiogenesis and then evolution took over from there. Or there's all kinds of beliefs that mesh
Yeah.
these two things.
Yeah, totally. I agree. And if somebody believes in evolution and that God used evolution, and I mean, if as long as God is the miracle maker, I'm not going to argue with them because if you have a miracle maker, he can do anything.
Hmm.
But evolution does need miracles. So
I don't think so.
somebody who says that evolution happened by like God set up the natural processes and then evolution, well, I might argue with them because I don't think evolution can happen without many miracles.
Well, like what I don't see a single example of a miracle that's required for evolution to happen. So
Well, I think your belief is very strong, but I give evidence showing how the mechanisms that are proposed for making evolution happen have demonstrably shown to be very insufficient. So,
I don't think that you have demonstrated. I mean, I know that you believe that, but like
well,
claiming that you've demonstrated that is a little bit different.
every week I come on here and I share a challenge before
Mhm.
I let you guys on. And I have a whole list right now of challenges that no one has questioned me on.
Okay,
Now there's
let's go through them. I'm
all right,
happy to question you on them.
let's do it. Hold on, that's not it. Okay, wait. I'm gonna have to reconfigure our screen here
Oh,
so I can
I
not
can
have
chill over
you
here.
talk. What?
I can chill over here. It's fine.
There we go. All right. So today I brought the math problem. I brought seeds.
Hmm.
Okay. Alternative splicing, ribosomes, circulatory systems, gene origination, DNA code, metabolic pathways, metamorphosis, coevolution of enzymes, helicase, nuclear pore complexes. Sal brought that. Collagen and blood vessels in dinosaurs, Cambrian explosion, millions of fish fossils, no predecessor to fish, thousands of dinosaurs, no predecessor. Now, someone has informally challenged that, and I
Yeah.
would
Oh,
say,
well, I did like several of these last week, right?
okay,
You can
you
cross out Cambrian,
informally challenged. You informally challenged. I
but
like I said,
you can cross out some of these on the list already because we dealt with them last week and I explained them. Like Cambrian explosion, that was dealt with. You can cross it out. No predecessors
no.
to fish. You can cross that one out because I listed some yesterday or
But
last
wait,
week.
you did not look. You we talked about the Cambrian explosion.
Hmm.
Okay. And you said, "Oh, look. See, we have this in the Ediacaran." And you said,
Hmm.
this is a very simple organism and basically so this is showing the progression. But you showed me an organism that I mean, first of all, every organism there's nothing that can be called simple in reality. I mean,
Well, simple is a relative term, right?
yes,
So it's simple compared to other organisms that are more complex. It's not simple compared to a rock.
right. But you basically painted the picture that, oh, this could come about by a very simple body plan and
Mm.
just, you made it as if like this organism could come out of nowhere and it wouldn't be a
Well,
problem.
do you understand like how Hox genes work? Because like Hox genes are responsible for building up our body plans.
Yes.
And so in terms of like the genetic switches and the kinds of chemical gradients that would be responsible for body plan of like Spragina, which is what we brought up last week, that is much more simple than like something like a trilobite or something from the Cambrian. So, you know,
Right, but a Hox gene, do you know how many nucleotide, how many base pairs a Hox gene is off the top of your head?
not off
I
the top
don't.
of my head.
I don't. Okay, but
Okay.
most genes are, at least
There's going to be
1,000
a
or
lot,
more,
sure.
right?
Uh-huh.
It's a lot of information there.
Hmm.
So, where did that information come from? That brings us
Well,
back to our information question.
we have examples of more simplified versions of Hox genes, like the predecessors for Hox genes occurring in animals with radial symmetry, like jellyfish. So we can see like how these things like we can see like more simplified versions of them in like more basal types of organisms. So it's not like these things just
Well,
come out of nowhere, poof.
Well, remember that all of this is based on your belief about common ancestry. So you're seeing this as a predecessor. And I see, okay, a similar gene, and I don't assume that that had a common ancestor.
Right, but
So,
you asked, like, where did the
yeah,
predecessor for this come from? So I'm just answering
I'm,
you
I'm asking where
from
the
the evolutionary
information
model.
came from. Boil it down to the simplest Hox gene that you can, that exists. Simplest Hox gene that exists. Where did
Mhm.
the information come from for that gene?
From a more simple version of that gene that may have done some other function that was only somewhat related. I mean, like at every point, like unless this is just a de novo gene that came from a non-coding region of the genome, then it came from mutations of another pre-existing gene that may have done another similar function. Uh, this is just the mechanism by which evolution works. I mean, we see examples of this like with myelinase and things like that, where you have a couple mutations to an enzyme that changes the kinds of functions that it's able to do. So like, I do say that the Ediacaran fossils should just allow you to cross that Cambrian explosion thing off of the list. I mean, we do. It's not like these things just come out of nowhere. Like we have precedents in the fossil record for them.
No.
So like it's not a problem.
No, because I brought up trilobites. I said, where did where's the predecessor for trilobites? And you brought up this creature and you said, well, this isn't really in the ancestral line of trilobites,
Mhm.
but this is another organism,
Yep.
right? Like a
Yeah,
simpler organism.
the reason why I brought it up was because it is so similar looking to trilobites that most people that are not experts would look at it and just think that it is a trilobite. So like clearly the trilobite is not just like an unprecedented form that just popped into existence at the Cambrian explosion with nothing beforehand that was even similar. Like there's in the Ediacaran fossils that literally most people would just think are trilobites.
Right. But the point is, you said they're not so similar. So that's not a predecessor. So you still have to explain where did trilobites come from and all the other forms that are in the Cambrian that were not in the Ediacaran.
Yeah. And
So the
we
Cambrian
do have
explosion has not
fossils
gone
that
away
are
as a problem.
I don't think that what you're saying tracks, okay? Because we do have examples of basically like pro arthropoda. So like trilobites are arthropods. So they share in the evolutionary model, they would share a common ancestor with all other arthropods. And then you look at what kind of characteristics that such an ancestor would likely have. It'd probably be like a tri-segmented worm. And we look in the fossil record and we find Eulingia. Like, I mean, we do have the fossils that would be fitting that description of a transitional form that we're looking for. So I just don't think that like you're aware of enough Ediacaran fossils. And like again, like the Cambrian explosion stuff is old news. That's like from the 60s. We've in the 90s, the 2000s, we've found all these Ediacaran fossils that just render it mute as a problem.
Well, I think even your side will admit that it's still a problem.
I
So
don't
I
think so.
don't accept this. I don't accept this.
I think that the only
if you
people that talk
look,
about the Cambrian explosion anymore are the ones on the ID creationist side, and they're using talking points from the 1960s and 50s.
right, but that are still an issue that maybe some evolutionists don't want to talk about, but that doesn't mean it's not an issue. But look, we're just going to go back and forth on that. If you disagree with me, bring your evidence that it's not a problem.
I've given
Okay?
you the evidence already.
No,
Eulingia.
that is not evidence that it's not a problem. So do you admit that there's an appearance, a sudden appearance of most of the body plans that we have today in the Cambrian?
No.
The basic ones. I'm not talking about, mammals
No.
and all that.
Again,
Okay.
no, I don't, because there are many body plans that are predating. We have Ediacaran fossils for bilaterian body plans. We have Ediacaran fossils for jellyfish, for a lot of different phylum in the Ediacaran. And a lot of different body plans today are not found until after the Cambrian. So I don't think it's most body plans that just pop out of nowhere with no precedence in the Cambrian. I don't think that that's an accurate summation.
Okay. Look, of the like major categories of
The
phyla.
phylum.
That's my understanding. Okay, but
Yeah, but again, those are
look,
talking points from the 50s and 60s before we had the Ediacaran fossils showing that
well,
those phylum go before the Cambrian back into the Ediacaran.
I feel like we're just going back and forth on this. So what I want to say is just talking about this does not mean you're bringing evidence. You have to actually bring something that is concrete, okay, for me to accept it. And for
What
me
I'm
to
saying, you're dismissing it as not concrete, but I think that that's arbitrary. Like, what about what I'm saying is not concrete? I mean, Eulingia, that's a fossil, that's concrete. The
but
Ediacaran fossil is concrete.
what is not concrete is that you're saying the problem goes away because of this creature in the Ediacaran. And I'm
Mhm.
saying, no, the problem doesn't go away just because you found a different creature in the Ediacaran. It doesn't make the problem go away. Now, if you disagree, then bring your evidence then that why it's
Well, the
because
evidence is that the phylum, like the phyla that were used to think, like people used to think that some of these things, like bilaterians and arthropods and jellyfish, just appeared suddenly in the Cambrian explosion. They used to think that in the 50s and 60s. But then, since then, we have found fossils predating the Cambrian explosion of those phylum. So like it's no longer a valid criticism. That's why. Like I mean,
Okay,
if we
well, I
found
mean,
that
look,
in the Ediacaran.
I will look that up, but I'm like, I don't want to go on wild goose chases when people come in and like rapid fire say stuff, but they don't actually bring evidence. That's why I like, because
But how I
I
feel like
do have limited time, but
okay, then are you just not accepting any spoken word as evidence?
um I would like to see something concrete. Like what I mean is like
You want
it's
me to
not
like
that
have a presentation? Do you want to bring a physical copy of these
I want you to
fossils? Like
bring
what?
something physical. Look, because I mean, look, this is for practical purposes. Okay. Practical in that I have a time limit on
Okay,
how many things I can look into. Like,
right.
Dr. Feldman came in and he rapid fire lists off a bunch of stuff. You
Mhm.
come in, rapid fire list stuff. When am I going to have time to take down all these rabbit
Sure.
holes? Look, let me give you an example. Dr. Thompson came in last week with his canid, with
Yes,
his
he gave you an entire
Bushnell
presentation.
Maydog. Yeah, and that is awesome. That's exactly what I need. And now tomorrow I'm doing my presentation on my findings based on his evidence. So,
Okay.
and he's going to come back on. So that's what I need because I need concrete things. So if you're saying, look, I have these quotes from these professionals, these people in the field that say the Cambrian explosion is no longer a problem. And, so and so said it, here's their credentials, then that gives me something to look into. And they have to give reasoning or whatever.
Okay.
You know what I mean? Bring a
The
paper,
issue
bring a,
though is
yeah.
that you yourself, you say that every single week you're bringing up a new point. You're saying that you've got all these points, right?
Yes.
And that nobody's addressing them. But then like as soon as I try to address them, you say it's not sufficient because I haven't done my homework to bring you like a bibliography associated with each of it. But like again, I think that you in citing all of these problems, you have a responsibility. If you're gonna say that something is a problem, like I shouldn't have to do your homework for you. Like if you're going to come out publicly and assert this is a problem, then you should also look to see if that problem has been addressed.
Yeah, and that's exactly what I did with this. So I brought my evidence today that there are math problems with evolution. Okay. And this is the evidence that was brought forward in 1966. And I said, look, I look at this equation, it means nothing to me. So I can't actually evaluate this. Okay. But I did try to look up and see, are there answers? Are there responses to this? And
Mhm.
it does not look like there are good responses to any of these points that these guys brought up in 1966. Still today, there is not a good response. So
Really?
if
Because
you
I mean,
want to,
I feel like that was just a failure of research on your part then, because this is like an old tired hat like argument, and like I've seen
okay, it
numerous.
might be. It might be a
Yeah.
failure of AI. Could be a failure of AI. Okay. So but you have to do more than just type in one question and then you know what I mean, you have to actually like look at the response and see what is this response saying, does this actually address it. And
Mhm.
that's what I did, and I found out that none of the responses that AI gave me actually addressed any of the issues that these guys brought forward. And in fact, when I challenged AI on it, it actually ended up changing its story about one of the things.
Mhm.
So what I'm saying is like, if you want to challenge the math problem, then look at one of these math problems and
Mhm.
say, okay, this is incorrect because of this. And if you don't do math, then you don't have to do the math one. Do something else. Every time I'm like bringing papers that are actually by evolutionists to show the problems with some of these issues related to evolution. So that's what
Yeah.
I'm asking for.
But then when I okay, so hmm, because basically it just sounds like um okay, yeah. Okay. So basically I need like if you're going to present the argument and then open it up for criticism, but then anyone that is going to critique your argument needs to have already in advance prepared a bibliography for you, then this is not a very appropriate format to be doing that, right? Because you just for the first time presented this, like the
Yeah,
way that you've set this up
right.
is that you present your presentation and then you want people to push back on you, but you don't accept any pushback unless it's a pre-prepared in advance, which they can't possibly do because you just presented it in the same stream.
And that's a fine point if I was limiting it only to challenging what I said today. Okay. I have all the, you can go back and look at any of the challenges that I presented for evolution, pick one, look at
Mhm.
what I said about it, and then come on next time and hit me with your response. And that's why, I didn't demand, I actually said at the beginning, look, if you don't want to come on and challenge the math here, and I don't expect anybody to come on and share any of your evidence for evolution. So I'm not limiting it. You can go back and challenge anything I said in the past.
Okay, so can we see that list again of the different things?
Sure.
I would point to other things like haiku ichthyes as predecessors for like modern fish. There are some that it's like ambiguous whether or not it even has a head yet because it's such a predecessor. Um,
Well, can you bring a picture of that fossil? Can you bring a
sure.
paper talking about how it's a predecessor?
I mean, sure, yeah.
But I mean, look, I don't want to wait while you Google right now. Like, go find your evidence, prepare your evidence, and then come back on and hit me with the evidence, right? Like, I like figure out if what you're saying is true, but and you have a good response before
Well, I do, but you just don't accept it unless I present like a whole like PowerPoint with it. Like, if I can tell you right now, like haiku ichthyes is a good example of like a very early transitional fish. But like then you're like, well, just because I know something and I can say it in a conversation is not good enough because
But
you
do
want
you
to
see
fix
what
it.
you're doing? See, you're putting the burden on me to
Yeah.
go look up this
Yes.
predecessor,
Yeah.
right? And so you're putting all the evidence burden on me. And
Hmm.
what I'm saying is, I can't do that practically. I figured that out very quickly because people come on and they go boom, 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 but they don't actually, they just say it. And then I have to go respond to it. So I had to change my method because every week, like at the beginning, every week I was going away and having to spend so much time looking up every rapid fire thing that people, I cannot do that. I don't have time for that. So the evidence burden cannot be completely on me. My evidence burden is based on the things that I bring forward. Um if you have evidence you want to share, you can't put that on me to look up. You have to present your evidence. Okay? You present it, and then if I don't respond to it, then it gets to count as my on my list of evidence for evolution.
Okay, then this seems kind of like in the workplace, what's oftenly said, like this meeting should have just been an email. Like it sounds like this, like the kind of our discussion that you actually want to have, it's much more conducive to have via email. Like that's what it sounds like. It sounds like a live stream is not really what you should be. That's not really what you're looking for, right? That's not a good format that's conducive for the what you're asking for.
Oh, emails are so much more boring though, aren't they?
They are, but that's in an email.
Okay.
I could send you papers and I could send you things, and then you would have enough time to look it over and then respond. But like the things that you're asking for to get out of this are really just not conducive for this format. But I guess that'll have to be the last thing that I say because I kind of do have to go. But
All right. Well, if you don't like the format, don't participate. That's all
well,
I
I
can
like
say.
talking with you, Rebecca. But like I have responses to the things that you bring up, but then it's just like you're not going to accept it unless it's in the form of an email or a PowerPoint.
No, do not send me an email with this. I don't have time to read all these emails. And people do this. They send me like
But if
papers
you're
and
asking,
papers.
but you're literally asking for it. You're saying like, show me your bibliography. And now you're saying, I don't have enough time to go through a bibliography.
I want you to condense your evidence and present it and give me a source. And then
Okay.
that's the kind of thing I will look up. Like I looked up the main wolf. I read Dr. Thompson's paper that he presented, and now I'm ready to respond
Okay.
to it.
I'll
Okay.
I'll email you, Rebecca. I'll email you. Good night.
All right. Good night. Thanks. All right. Well, everyone, okay, thanks for joining. And I am going to go over my scientific reasons that you should reject evolution since it got interrupted at the beginning by somebody coming on. So, proposed mechanisms are grossly insufficient. And what are those proposed mechanisms? Let's see if I have it here. Yeah. So there are others that could be listed, but the point is easy to see when you look at this. So natural selection, genetic drift, gene flow, horizontal gene transfer, symbiogenesis. Now, all of these are fine mechanisms, but the problem is they do not supply new information. And information is what you need for systems and organs and all the things, all the features of life. You need information. Mutation is the only mechanism that is able to provide new information. And the problem with that is that the new information that it provides is usually either harmful or neutral to the organism. And it does not show the capability of being able to produce new organs, new systems, all the things that you need for life to diversify. So, proposed mechanisms grossly insufficient. Number two reason, mutations are, it is known that mutations degrade. Okay, they degrade. In fact, I was looking this up tonight because I was looking at the back and forths about mutations for this math problem that I was showing. And it mutations as we observe them right now are having a negative effect overall on organisms. Now, you know, there if you assume common ancestry, then you could say, "Oh, but see, then we know we're not extinct, so this isn't a problem. We see that, mutations, but there's all this reasoning that depends on the presupposition of common ancestry. So, mutations, as we observe them now, are a negative thing. It's not a good thing. They're going in the wrong direction for what evolution needs. Okay. And there's a really good book on that by Michael Behe. It's called Darwin Devolves. And he really lays out the evidence that, look, this is a problem. Evolution is working, these mutations are working in the wrong direction. So, third reason, scientific reason to reject evolution is integrated systems require foresight and planning. And we know that. Like, this is something we know. Every integrated system that we look around at, it needs engineering. It has to be planned. It's not something that can come about. You can't just build a bridge by, adding a little thing here and there. You have to plan out how it's going to work. Life is all integrated systems. Even a one-celled organism has many things working together in harmony, and that wouldn't be effective at all if they just had one thing or two things or whatever. So integrated, every cell in life is an integrated system. And then when you get complex organisms like animals and plants, then you have harmonization at many levels. You have integration at the cellular level, and then the organ level, the system level. And so this is something that it is not feasible at all for that to happen by a natural process. At least no known natural process that we can observe has shown the capability to be able to do that. Numerous chicken and egg problems. Number 4, numerous chicken and egg problems at the cell and system level. Not only does life need planning and foresight, so many things have to be in place at exactly the same time in order to benefit the organism. but there's so many things I can mention. Let me just mention ATP. It's what's powering a lot of the functions that are happening in each of your cells. But did you know, in order to get ATP, you have to already have ATP, because you have to build ATP synthase, and you've got to build that with ATP. So this is the kind of thing where it's like, well, which came first, the ATP or the ATP synthase? You have to have both in place for the functioning. Now, some people like to pass these things off and say, well, the first life probably didn't have that. Well, all of life has it today. So why is it that all of life like has so many of the same properties at work at the same time? And there's just so multitudes of chicken and egg problems. I only just mentioned one. There's multitudes. Okay, so fossil record number 5, the fossil record sudden appearance of forms, which Grayson argued a lot with me tonight about that. But this is a problem. And, it's not my favorite problem to talk about, because for me, the first 4 I listed are enough to just absolutely demolish evolution. But one of my kids actually brought it to me and said, well, wait a minute, but all of those 4 could still be like, let's say you believe that God used evolution and that God was able to do miracles for evolution. Then if you believe God did miracles to make evolution happen, none of your 4 things are like a reason to reject evolution. And I realized, oh my gosh, he's right. So I added in these 2 reasons, okay, even though I think they're not as strong as my first 4 reasons. But just in case you're one of those people who believe God could, have done a lot of miracles to make evolution happen, to take care of all these other problems. Well, should we believe it based on our observations of the fossil record? It seems like the fossil record has a lot of sudden appearance of forms, sudden appearance of angiosperms, like Dr. Feldman talked about tonight, sudden appearance of fish, sudden appearance of bats, sudden appearance of all kinds of things in the fossil record sudden appearance of all types of wings. Every type of wing just appears. So we have all these sudden appearance of forms, okay? And that's not really what we would expect if this all progressed over millions and billions of years, the development of life. We would expect to actually have many more transitional forms leading up to a wing than just a wing out of nowhere. Okay, so that's a reason to reject evolution, even if you have a miracle working God to take care of the other 4 problems. Another one is the phylogenetic trees are a mess. Okay, so if we all evolved from a common ancestor, then we should see like a nice, neat tree of like, okay, well, these things, they morphed in this way, and they're over here, and their genetics match with the proteins that are inside of them, and their morphology matches with their genetics, and all of these nice, neat little trees. But what we actually see is a mess. So you have like organisms that have this trait over here, but there's organisms on the total other side of the tree that have the same trait that was supposed to evolved again, it separately, but like exactly the same type of thing. Well, it's already highly improbable for evolution to make something once. So to get a feature a second time or a third time or 40 times, like they say, eyes supposedly evolved separately 40 times. 40 times you're supposed to have this complex structure coming together, all of the things that need for it to happen, all coming together, like eyes coming about 40 times. Wow. And why do they say that? Because they're spread out on the tree and they don't match genetically. So there is that's all over. So there's no tree of life that makes any sense. Okay. And you'll see that contradictions, even if you just read papers about evolution. Look up the evolution of anything that you are curious about. Look up the evolution of it and read whatever scientific paper comes up. Every time I do this, I'm serious, it has never failed yet. Every single time there's an example of convergent evolution where the same feature is supposed to have come about in a different lineage. So those are my reasons, scientific reasons to reject evolution. Thank you all for being here. And let me see if there's any comments. So, anyway, thank you guys. Thanks, Tom, for your participation. Even Dr. Dan's here. That's cool. So, all right. Have a good night, y'all. And thanks for watching.